It is today more vital than ever that we have long and reliable historical records of the Earth's climate. Thanks to the abundance of modern observation methods, our weather records for the present are quite complete. The problem is, these observations are not evenly distributed around the globe, and there are also fewer and fewer of them as we go back in time. Climate reanalysis can solve this problem. It combines observations made in the past with today's weather model to deliver a complete and consistent picture of the past weather. Imagine the weather of the past as a series of jigsaw puzzles with pieces missing in some places and overlapping in others. The pieces we have are observations coming from weather stations, weather balloons, aircraft, ships, satellites, and other sources. The reanalysis is like a smart machine that uses the weather model to combine and process all the information from those pieces. Using the laws of physics, it is able to blend overlapping pieces and recreate pieces that are missing in a consistent way, thus restoring the complete puzzle. The reanalysis delivers a global picture of the weather and climate of the past as close to reality as possible for each and every hour, from the Earth's surface to the top of the atmosphere. The data produced by the reanalysis are widely used and provide many kinds of information, not only about the atmosphere, such as temperature, wind, and precipitation, but also about the ocean and the land surface. As such, reanalysis represents a comprehensive historical record of the Earth's climate and provides an accurate way to monitor how fast it is changing.
Temperatures are rising, and with them, the land and the ocean become warmer. Dry soil gets drier. Ice melts faster, and the sea level rises. The Earth's climate is a complex system with many interacting elements. To form a coherent, trustworthy picture of its state, we need regular measurements of the atmosphere, oceans, and land. That is why the essential climate variables, or ECVs, were identified. A set of 54 key climate components to be measured and monitored to understand different aspects of the climate system, how it is changing, and the best way to adapt. The Copernicus Climate Change Service, or C3S, provides the most comprehensive data collection of essential climate variables in a single platform. From the past, thanks to the extensive archive data available, it is possible to recreate long records of ECVs. To the present, the cutting-edge and quality-assured data from these variables is essential to understand the current state of the climate system and the changes happening. Into the future, ECV's data can help improve model predictions and guide decisions on the best way to adapt to the effects of climate change. The number of essential climate variables available in C3S will keep growing as science and technology develop, adding to its expanding set of climate products and tools that combine satellite data, in-situ measurements, modelled and rescue data, and reanalysis across air, land and ocean. The Copernicus Climate Change Service is the one-stop solution for your climate monitoring needs. Access our climate data store and find the data you need to make smarter decisions. Where is the best place to build a wind farm? Could changes in rainfall cause flooding in my region? How will trends in sea ice impact shipping routes? To find the answers to these questions, you need climate data. But just as not all tools are appropriate for every task, not all data sets will suit every need. Do you need long-term records to understand trends? Or shorter-term records for details of the current situation? Data for a specific location or an overview of a larger region? After considering questions like these, you also need to take into account other limitations of individual data sets. So how do you know you have the right data for you? The Copernicus Climate Change Service, or C3S, has created a user journey to help you. It starts with a detailed account of each dataset's strengths and weaknesses. When you look in the Climate Data Store, for each dataset you can find answers to questions like: how were the data produced? Are uncertainties in the data documented? Is there a user guide? If you are still not sure you have chosen the right dataset, you can visit the Knowledge Base, a collection of articles checked by experts that acts as a user manual. And if the Knowledge Base does not answer all your questions, you can learn from the experience of other data users in the forum. At the end of your journey, if there is anything left unclear, contact the Support Help Desk, and they will help you navigate any final hurdles. You can find answers every step of the way to make an informed choice about the data that best fit your needs.
Great, thanks, Rafaela. So please be muted.
A very, very warm welcome. Good afternoon to our virtual audience and our esteemed speakers. Yes, you are in the right place. This is the C3S Conference and General Assembly, and it's organised by Copernicus Climate Change Service, C3S, with the support of co-hosts, the Italian Copernicus National User Forum. Now, this is the final C3S General Assembly of its first phase before a new contribution agreement is signed by ECMWF with the European Commission. My name is Katrina Sickle. I'm a moderator, sometimes a broadcaster, but I have the pleasure of navigating us all from my home office in Brussels through this event with 6 whopping content-rich sessions that showcases a raft of excellent speakers drawn from across the stakeholder ecosystem. Now, in fact, just a point to say, larger this time than the C3S family. And since you, our audience, does represent a really broad range of stakeholders with different levels of knowledge and different levels of interest, we have asked all these brilliant speakers to pitch their contributions to suit the maximum number of tastes and ways of receiving information. Of course, our shared starting point is the following. Every single member of society is exposed to growing climate risks, and that successful adaptation to these risks is only possible through reliable climate monitoring and access to transparent and traceable data, products and services. So with that in mind, over the course of the next 3 afternoons, we are going to be showcasing what has been achieved in the last 12 months, of which there is plenty, but we're also going to be looking forwards. We're going to examine the needs, the challenges, the opportunities for climate data, and of course, therefore, for C3S in the next 5 to 10 years. Now, I know you're eager to meet our speakers, but before we dive right into the content of this opening plenary, I'd like you to kindly just lend me your ears a moment longer. I've got to get a little bit of that housekeeping stuff out of the way. Now, this is a fabulous platform, Swapcard. It's not all going to fall into place with you right now, so you'll need to have a bit of a play as the day goes on and tonight. But each day, let me start by telling you, today, tomorrow, Thursday, there's going to be a poster session between the 2 90-minute sessions. And in that poster session, you can watch a show reel of video posters that showcase C3S and its use of data, and you can even chat and interact with the C3S community there. You can do the same thing with partners and peers in the virtual marketplace. So you can do that as you would at any physical event. And you can find some virtual booths in that marketplace that are managed by the C3S partners, and they'll showcase lots of their own stuff. The important thing that you can find is you can meet and speak with people. You can book a chat, you can book a video call. And if you click on the profile of somebody else who you kind of take a fancy to, I mean, content-wise or otherwise, what do I know? I'm not saying anything. Then you can send them a request for a chat. So another participant, a speaker, a booth, have a play around. You can see that if you click on somebody's profile. You can also set up some meetings. If you want to make use of this platform between 10 and 2, you can set up meetings for that time. You can find that on the Swapcard platform. And if you have any problems, what you can do is post a question in the general chat. Now that's important. There are different ways that you can interact. There's a kind of a general chat column where you can ask questions as we go along. They could be technical, they could be logistical, help, nothing about your marriage or your cat or what chocolate you think you should be eating. No, stuff relevant to this event. That's the general chat. And then in that chat area, there's a place to pose questions, which I will be able to pose. They'll be curated by the organisers to our speakers in the debate sessions. And there's a place for polls, because I'll be asking you to take part in 3 or 4 polls every day. You can tweet at any time you like, so that's another way you can make your voice heard, and that is, of course, hashtag CS321. So have a little bit of a smooch around that platform and see the different opportunities that you have to interact with fellow participants, speakers, partners, C3S staff, but also with the speakers themselves within the framework of each debate. 2 very other important things before I move on. Speaker presentations. Don't panic, you don't need to snap them on your mobile phone. They will be available on the Swapcard platform until the 4th of June and on the C3S website. And likewise, recordings of any of the sessions that you might be such a geek, you want to watch the same one again and again, or share them with somebody, or you missed something and you'd like to come back to it. So this Swapcard platform is going to function until the 4th of June to enable interactivity. And then you can also get presentations and links to the recordings on the C3S website. So I think that's most of the important information for now. Bear in mind that C3S will send you an event summary. You'll be able to have a look at that, but that doesn't mean miss the event, and a request for you to fill out a very simple evaluation form. It doesn't need me to tell you that this is a beast of an event for C3S to have put together. So they'd really like your feedback to understand how best to frame future events to fit your needs. Now, I hope that's everything. Look at that. Where are we? 8 minutes. I've got 1 more minute and I will be on time. So if you can go into the chat area, ladies and gentlemen, you can go into the agenda on Swapcard. You can click on the opening plenary. You should be able there to see live discussion. And in there, you should have an option. I'm doing it on my phone now. That's why I'm looking down. You should have an option there for polls. And there's a first very simple icebreaking question. Why are you attending this event? So let's see if anybody is awake enough and technically minded enough. God, you must be. If you're coming to this event, you must be technically minded enough to put some input in there. Why are you attending this event? Now, I've got it on my phone. I'm not sure I know how to get the answer. I haven't got anything in yet, but maybe, aha, that's what I forgot to tell you all, ladies and gentlemen. We do have a 30-second lag. I forgot that, between where I am in Zoom with my speakers and where you are in Swapcard. The hashtag again, hashtag C3S21. C3S21. And no worries, if it's taking a long time, we will move on without the poll, but I'd quite like to hear why you're with us. Let's just see. C3S for sugar, obviously, 21. That's the hashtag. And hopefully, if I give you a little bit of time, we have a poll, but I'm reading the chat in Zoom where I'm actually speaking to with the delightful technical crew. And if they tell me that nothing's come in, then I will move on. Oh, results are ready. Results are ready. Well, I can't see them on my phone, but maybe you need to post them. So I'm going to let the lovely Vincent from behind the scenes to give me some results. I don't see them in the output. But if you good people see the results, maybe you can tell me this, then that's all good for me. I cannot see, or maybe somebody can tell me what the main reason for attending this event is. We'll wait and see. I'm just giving it a bit of lag. We're all in the little baby steps at first, ladies and gentlemen. Here we go. Oh, there's a screenshot, but I might not fiddle with that too much, ladies and gents, because that's quite hard for me to No, that's too difficult. We'll find another way for me, but I hope that you, ladies and gentlemen, have seen what the outcome of the polls are. I'm not going to fiddle anymore. I'm going to stick rigidly to time, but I am going to be asking you to keep taking part in those polls. So have a wander around the platform. That is the main message from all of this preamble. So let's have a look. Who are our speakers in this first opening plenary? It would be great if we could see a speaker slide. It's a good reminder for you, even though the information is obviously available on the platform. There we go. Just take a heartbeat of a moment to look at this fabulous opening lineup of speakers. I'm going to ask each to present one by one, and then I'm going to bring 3 of them back towards the end for some curated questions. Let's get ready then, ladies and gentlemen. I'm going to invite our first speaker to join me. I said that this event was co-hosted by the Italian Copernicus National User Forum. And on behalf of that forum, we have Vice President of the Emilia-Romagna region in Italy, Ellie Schlein. So hello, so lovely to see you.
See you too.
Hello, so nice. I'm squinting like, do you know, everything is so teeny. Look at me, I'm having to wear glasses. It's just horrible. I feel like in the last year I've aged 100 years and now I just need to keep getting new glasses. Welcome. I'm going to directly hand over to you and allow you to just take a few minutes to officially open this 3-day extravaganza. Over to you. Thank you.
Thanks a lot, Katrina. It's a pleasure for me. I welcome you all on behalf of Emilia-Romagna, our region, and I welcome you in the city of Bologna, at least virtually. We are glad to host the conference of CS3 and the Copernicus Climate Change Service General Assembly and the conference connected. So it's we know that climate change is one of the biggest challenges of our times, and we urgently need to address it with a data-oriented approach. It's particularly important for us being decision makers. Climate data are really crucial to prepare effective climate change adaptation and mitigation strategies that also need cooperation between different institutions from global to European level, from national to regional and local scale. The ecological transition, we know, requires to be effective and just, to be accompanied by a concrete implementation strategy that sets also binding targets to reduce greenhouse gas emissions across all different sectors of the economy, starting from agriculture, transports, industry, clean energy, and good and transparent climate data will also be crucial in setting monitoring platforms for the efforts that we are doing to reaching the ambitious goals of our climate agenda and the 2030 Agenda for Sustainable Development. We need to invest in research and technology, in education and competences for the transition to make sure that we accompany all society through this huge change. And starting from workers, that we will need new competences to start and also sectors of the green economy, and also not forgetting the most fragile parts of our population. We have learned through the pandemic to listen to science, at least on health issues. Now we need to urgently do it also on climate change, because scientists have warned us for decades about the risks of the devastating consequences of the rise of global temperatures, and we are compromising the capacity of our ecosystems to regenerate themselves and of all of us to live on this planet, and it's the only one that we got. So the Emilia-Romagna region is concretely implementing these principles through a pact for work and climate that we have co-signed with all the regional system, municipalities, universities, but also enterprise organization, trade unions, civil society organization, and also some climate organization, because we know that we need to do an effort in our different roles in society. So we have shared key strategies in order to rebuild a resilient, inclusive economy by creating new enterprises and new jobs through an ecological transition that cannot wait any longer. So we also set two ambition climate goals. One is to go through 100% clean energy before 2035. And the other one, which is quite ambitious as well, is to set already a decarbonizing strategy for our region within 2050. But we need already to set the intermediate targets and the implementing strategies that we need to get there. So just to go to our conclusion, you know that we have done efforts to transfer the European Center for Medium Range Weather Forecast data center from Reading to Bologna, and also the simultaneous launch of the Italian Meteorological Agency here in the Technopole of Bologna. And these investments have gone through despite the pandemic. We really believe in this direction. In Bologna, we will have also some important investment on big data. Also, in the occasion of this General Assembly of the Copernicus Climate Change Service, we confirm our commitment to boost and strengthen in Italy the role of advanced training and research in the meteorological, climate and air quality fields at service of the whole European Union. So this is why we are so committed with Alma Mater, with the Italian Center for Research, CNR, but also Enea and other important actors. The Italian government and the region have invested in this direction, and also in some other cooperation at the European level, like, for example, the integrated Life IP Prepare project that is led by our region and dedicated to the improvement of air quality in the Po Valley. You know, it's one of the most polluted valleys, unfortunately, in Europe. So we need you. We really need you. And also, just me to conclude, let me also remind the Copernicus Mirror program. We started already closely connected to other core services of Copernicus. We recall the service dedicated to the air quality, which was already shown during the user workshop that Italy dedicated to Copernicus Atmosphere Monitoring Service and was hosted in Bologna in October 2020. The service has been developed by the Regional Agency for Prevention, Environment and Energy of our region, ARPAE, as part of the National Environment Protection System coordinated by ISPRA and realized with financial support from the Italian Space Agency. So, in conclusion, we need your precious work for real as decision maker, and we will commit in hearing your data and your conclusion and translate it into means that we need to reorient our policies and boost investment in this new crucial direction. Thanks a lot. Have a good day and a profitable conference.
Thank you so very much, and very, very eloquent. And I just, I think what's important there is the words that you started with. You said good data, transparent data. That's absolutely crucial. So we're going to have a discussion, I think, what good and what transparent mean in terms of data. And very interesting, of course, to reiterate, it's about all the players. There's global framework, national, regional, local. We're going to drill down into that. Certainly, you said again those words that we've heard a lot over the last year, listen to the science. And you just articulated some society needs. And of course, the importance, the data is also for the good of society at large. And within that transition, it's all about creating new jobs too. And it was really heartening to hear you say, listen, efforts, Katrina, have gone through despite the pandemic. So really fabulous. Thank you for your energy to kick things off. I'm grateful. And thank you for that beautifully ubiquitous bookcase in the background. I commend you for it. Okay, so stay tuned. You can take a break backstage, because I'm going to call immediately, in the interests of speed. They're not going to speak fast, ladies and gentlemen. They're going to speak less, but I am going to keep things rattling along at a nice pace. So who better to speak next than the Director of Copernicus Services at the European Centre for Medium Range Weather Forecasts, Jean-Noël Tupou. So hello, so lovely to see you. And hello. I'm going to, hello, I'm going to do a poll after you. I'm going to let you take the floor and sort of give us a flavour of what's been going on, where you're proud. Talk to us a little bit about C3S. Give us the headlines. Thank you.
Thank you very much, and good afternoon, everyone. And on behalf of ECMWF, it's really a pleasure for me and an honor to welcome you to the Copernicus Climate Change Service C3S conference and General Assembly. I think it's fair to say that with C3S reaching about 100,000 active users today, and just this 3-day conference gathering more than 1,500 registered participants, I can safely say that C3S has been and is continuing to be a success story. I have to say that more broadly, the bold vision of the Copernicus program, which is an unprecedented environmental program from the European Union, which combines satellites, in particular the Sentinels, in situ observations, as well as environmental core services with modeling infrastructure has really raised the bar in terms of what we could achieve as a service. So the combination of its full, free, open data policy, plus the long-term operational commitment to basically provide a continuous scan or a continuous MRI of our planet provides really the backbone for core services such as C3S, which vision is to really continuously provide authoritative climate information to its users. So what do we mean by authoritative here? We mean that the information has to be trusted, it has to be quality assured, it has to be traceable. And this is why C3S at ECMWF has been heavily relying not only upon its own scientific know-how and data and modeling infrastructure, but also, and equally importantly, if not more importantly, on the scientific excellence in Europe and worldwide. Be it within academia, the modeling centers, the space and environmental agencies, or meteorological services. So C3S would not exist without the underpinning science, which go into the data, the products, and the expertise. So basically, C3S would not exist without many of you. So now, with success comes a responsibility. So if the Copernicus program as a whole is a user-driven program, C3S certainly as a service is as well, and needs to remain so. So what it means is that being authoritative in a scientific sense is not good enough, and far from it. Indeed, information services need to be accessible, usable, and more importantly, fit for purpose. So beyond the projects and the use cases, which are of course very important, we really need to continue to engage with our core users, be it policymakers at the EU level, for example, in charge of defining directives in the context of the European Green Deal, but also national stakeholders, for example, national climate service providers, environmental agencies, etc., which can help us refining the information needed by the end users. And it's by listening, understanding, and responding to these evolving needs that C3S will continue to be an operational and valued resource to the big mitigation and adaptation agendas. So again, and as we embark for another 7 years adventure with the European Commission, probably next month or so, many thanks for being here today to all of you and showing your interest in C3S. And with a special thanks to our distinguished and outstanding speakers. And I really hope that you will find the next 3 days exciting and stimulating, and that you will collectively help us, and you have several channels to do it. You will help us continuing to improve and being even better in the future. Thank you very much.
Thank you. Takes me a heartbeat of a moment to put myself back on so that I'm not, thank you. First of all, can I, a very quick thank you for 2 lovely phrases you used there. I love that, providing a continuous MRI of our planet. That was lovely. Thank you for that great sort of image there. And also for taking a Spider-Man quote. You said, instead of with great power comes great responsibility, with great success comes great responsibility. And that was very interesting what you said, that if you might have disappeared. I was actually going to ask you, I think, a very important question before I pass to a poll and our next speaker, because I've actually figured out how these polls work, but I might have lost you now, Jean-Noël. Are you still there?
I am.
Have you run away? You're still there. Okay.
I am here. Yeah.
For a really concise answer, and you know me, I'm rapping on the door of brevity. You said there, you know, what does it mean authoritative? You said trusted. Traceable, it's got to be fit for purpose, it's got to suit the user. So I'm here and I say, good Lord, science is taking such a hammering, because when you come from outside it, like me, you know, you'll just go, but hang on, you're claiming your data's right, and then someone else comes along and claims their data's right, and the poor sort of general public and others, and even stakeholders stuck in the middle, kind of go, ah. So what would you say in answer to that? How do you speak for the veracity of climate data? And I don't call into question at all your services, but how do you answer that in an age when science is a bit under fire?
Well, I don't know if it's under fire, but the fact that we are basing our services on underpinning science data, and when you compare the other services and what they are producing in terms of of data of climate monitoring, and to see how consistent all the monitoring or all the message that the monitoring is giving. I think it's very reassuring actually to have many different sources of data which are coming to the same conclusion, because it means that the scientific community at large is really in agreement with what we are observing today.
Okay. So I know I was just putting in that, and feel free, anyone else who's on this first panel, to come back. And very, very interesting. And we are going to unpack even more, because I know it's more than data with C3S. There's a whole other operational services that I know that Carlo is going to talk about at the end of this opening session. So a poll. So the answer to the first poll, which I finally figured out worked, everybody, was that most of you are providers of services and you want to keep up to date. And I realized when I actually submitted an answer myself and refreshed it, I could get the polling to work. So would you mind if we just show a second poll, which is going to ask the question, if you're still in the opening session, who is best placed to provide climate data to society? Private sector, government, research institutions, or NGOs? So take a moment to submit. I'm submitting on my phone at the same time, so I will be able to read the results. And I know there is a little bit of delay, so I'm going to give some time for that and come back to it. So let's have a look. Who is best placed to provide climate data to society? And I'm trying to see the answers, but again, on my phone, it's I'm being let down by technology. So no problem. If anybody wants, there we go. Research institutions, I have 77%, followed by governments on 17% and the private sector on 5%. But I'm sure we are going to discuss how all of those different stakeholders fit together in the provision of services, and particularly in the evolving of the services, which we're going to talk heavily about in the last session of the third day. So we have two keynote speakers for you. The first keynote speaker is a lady called Valérie Masson-Delmotte. She is a French climate scientist and research director at the French Alternative Energies and Atomic Energy Commission, and she works in the Climate and Environment Sciences Laboratory. She's contributed to several IPCC reports, and she is co-chair of Working Group 1. So may I please welcome you, Valérie Masson-Delmotte. It's so delightful to, you're going to come shortly. There's always a little bit of a delay between things moving from where we are, which is in Zoom, to Swapcard, which is where the audience experience this event. But I'm going to hand over to you. If they can hear you, I can ask you to start. What are you going to talk about, Valérie?
I'm going to talk about the IPCC Working Group 1 report that is just being finalized. I hope you can hear me and see me properly.
I can certainly hear you. I can see. There you go. We are both. There you go. So I'm going to give you the floor. And even if we can't see you yet, we can certainly hear you. So please go ahead.
Thank you. So thank you for this invitation to join the C3S General Assembly, and congratulations for your achievements after your first 5 years of operations. And climate data, information and knowledge are playing and will continue to play a key role in climate literacy and in supporting adaptation and mitigation responses and policies. The broad audience of this meeting reflects a fast-growing community of users, developing new and tailored services for a range of topics and sectors, building on open access, high-quality climate data and tools, and based on the best available science. So let me develop a parallel with the efforts done by the Intergovernmental Panel on Climate Change, which aims to provide the best available science related to our changing climate, climate-related risks, and response options. And I'm really glad to inform you that 6 years into our 6th assessment cycle, the 12 chapters, the atlas, and the technical summary of the Working Group 1 report on the physical science basis of climate change have just been completed. Our concise draft summary for policymakers is currently under review by governments until June 20, in order to ensure that our summary is accurate, well-balanced, and clearly presents the findings of the detailed underlying report. I often describe the IPCC process as a co-design process between delegates from all governments and the climate change research communities. Our reports are designed to reflect new relevant knowledge developments and address needs expressed by governments. And this co-design is at play in the framing, the review, and the approval of each of the reports. The IPCC process is also designed to ensure the distillation in a concise summary for policymakers of key findings, grounded in a robust, rigorous, objective, and transparent assessment of the available scientific, technical, and socioeconomic literature. And I would like now to place an emphasis on the following question with examples from recent work. What matters most for the quality and relevance of our assessment reports? I would like to flag that the first aspect is related to the timely availability of new scientific information from multiple sources of knowledge, including, of course, observations, process understanding, modeling, and all the knowledge from scientists using these lines of evidence. And I would like to flag that the AR6 Working Group 1 report provides an assessment based on more than 40,000 peer review publications. It gives you a hint of the Herculean efforts of everyone involved. Without new knowledge, no new IPCC findings. The novel structure that you can see on the screen of the Working Group 1 report has been designed to capture our understanding of large-scale climate change for key indicators of the climate system. What is observed, including in a long-term context, human influence, near-term information, and scenario-based projections. And then our understanding of processes shaping the response of the global climate system and its regional characteristics, including, of course, the carbon cycle, short-lived climate forces which affect climate and air quality, feedbacks, climate sensitivity, and the Earth's energy budget, the water cycle, and the ocean, cryosphere, and sea level changes, which also include long-term committed changes. And finally, the report places a very strong emphasis on our understanding of regional climate change, including methods linking global and regional change, extremes, climate information for regional impact and risk assessment, an atlas of regional changes, and an online interactive version, which is a novel development. This structure was designed to support the combination of multiple lines of evidence. And in this report, when looking at future, for instance, global warming, we don't just report model results, but we combine scenario-based projections with observational constraints and the new assessment of the climate response metrics. And that's a major step forward. I also stress the fact that the AR6 Working Group 1 report has highlighted climate services, user needs, and regional climate information across 5 of its chapters. The second aspect for the quality of the report is the broad participation of experts from academic research and growingly from practitioners. Our report is the outcome of the work of 230 coordinating lead authors, and review editors from 60 different countries. They were selected from more than 1,000 applications and supported by chapter scientists, who are often early career scientists, and hundreds of contributing authors. We implemented inclusive and participatory approaches, which made it possible to complete our report in a pandemic context, working online for the last year. The quality of the assessment strongly benefits from critical eyes of thousands of reviewers. And just to give you a hint, we have received altogether 75 review comments from 750 and more than 1,200 expert and government reviewers so far. The approval session for this report is scheduled to take place remotely, starting in the last week of July, and if successful, as this is one more challenge in the pandemic context, the report will be released on August 9th. The summary for policymakers covers 4 main themes: the current state of the climate, our possible futures, climate information for risk assessment and regional adaptation, and limiting climate change. In the 6th assessment cycle altogether, as you can see from this just structure, we worked hard to enhance the handshakes across the usual silos of IPCC working groups and research and practitioner communities. This was enabled by the fact that we have jointly supervised 3 special reports on global warming of 1.5, climate change and land, and the ocean and cryosphere in a changing climate. Let me have a look at how climate services were approached in these 3 special reports. The 1.5 report stressed that climate services can play a critical role in aiding adaptation decision-making, depending on climate information availability and usability, local infrastructure and institutions, and also their ability to overcome technical, institutional, design, financial, and capacity barriers to scale up. The Land report concluded that there is a high return on investment in human and institutional capacities to develop and strengthen timely and effective climate services, including combining in situ and remote sensing monitoring systems and integrating biogeophysical and socioeconomic aspects. And the SROC report highlighted that marine climate services can inform flexible adaptation planning and implementation if they include a whole systems approach, when the services are sustained and context-specific, and with the sharing of data, information, and knowledge. There are several dimensions of integration across the 3 main working group reports on the physical science basis and the adaptation and mitigation assessments. These dimensions of integration include the new shared socioeconomic scenarios, global warming levels, cumulative CO2 emissions, as well as the risk framework. And let me finish with an emphasis on the risk framework. In our report, in the AR6, risk is the potential for adverse consequences for human and ecological systems, recognizing the diversity of values and objectives associated with those systems. And in the context of a changing climate, risks can arise not only from impacts of climate change, but also from potential human responses to climate change. The risk framework has led to the Working Group 1 report to place an emphasis on observed and projected changes in physical climate conditions, means, extremes, events, indices that are known to affect an element of society or ecosystems. And depending on the system tolerance, these climate impact drivers, that's the term we have coined, can be detrimental, beneficial, neutral, or a mixture of each across interacting systems and regions. The Working Group 1 report also places an emphasis on low likelihood, high impact events, recognizing the need to better inform risk assessment and decision making, including in situations of high uncertainty. I hope that this brief overview of novel aspects in the Working Group 1 report will trigger your interest, and that your community will strengthen connections between physical climate and impact scientists, and between academic researchers, practitioners, and stakeholders. There is a huge potential for coordinated strategies to enhance climate services best practices and share common methodologies. While there is a fast growth in products and activities, a major barrier lies in the accessibility of related knowledge. For instance, internal documentation from consultancy activities is not always publicly available and therefore could not be reflected in our assessment. I thus finish with the following things. I strongly encourage you to ensure that the peer review and the accessibility of products and methods is strongly anchored into the Copernicus C3S strategy, contributing to best practices and supporting future assessments of the state of knowledge. And the next special report from the IPCC in the 7th assessment cycle will be focused on cities and climate change, where there is an immense potential for combining multiple forms of knowledge between academic researchers and practitioners. Thank you very much.
Thank you. Thank you so much. Don't go away for a second. Don't go away. I have a very quick question. Now, ladies and gentlemen, let me just give you a heads up. It is likely in this opening session that we're only going to have 10 more minutes at the end with Valérie, our next keynote, and our final speaker of the session. So I've got enough questions. If there's a burning question for any of those three good people, I will endeavor to take it, but I think I might have enough. Valérie, I'm going to ask you something before you disappear. And, you know, it is clear from what you have said, and it's particularly interesting, that risk assessment, risk framework component that you, very fascinating. And I liked very much what you said about handshakes across silos. And that's critical, particularly in co-design, which you described at the outset. Climate data has never been as important as it is now, but it needs to serve societal needs. It needs to do it well. Does it need some kind of adjustment, some kind of step change in its operationalization? And if there are three, could you say what are the challenges you see, and keep it delightfully concise, if you could, please?
I think that there is a need to define a common glossary between the various users. That's an effort we have made within the AR6 IPCC report, developing a glossary across working groups. It's quite critical, in fact, to agree on the terms. That's the first thing. The second thing is when working on the availability of data, place a strong emphasis on the use and the availability of data for training and education. I think there's a massive effort that can be done to make sure that during training and education, higher education activities, the latest cutting edge information can be mobilized and used. Mm-hmm. And the last thing is the importance of providing an assessment of the quality of information in a transparent way for the users, so that they understand the added value of work directly with the research community and the maturation of the state of understanding of the products.
Okay, thank you very, very much. Thank you for that very, very comprehensive look there. And I will invite you back towards the end. Do not disconnect, but you can just put your feet up backstage momentarily. And let me take this opportunity to two things. My lovely speakers, don't share your screen until I've asked you to come and join me, because that helps the technical people just set us all up in the live stream. And secondly, to our lovely audience, I won't be taking a lot of questions from you in this opening, but I will elsewhere in the event. Questions, remember, stick them in the chat at any time if something can be answered by C3S staff. So as I said, we are spoiled. We've got two keynotes in this first opening session. Our second is a climate scientist and director of the NASA Goddard Institute for Space Studies in New York. He's recently been appointed as the senior advisor on climate to the NASA administrator. His name is Dr. Gavin Schmidt, and I'd like to ask you to join me. Don't share anything but your good self for the moment. There you go.
Hi, thank you very much.
Hello. So what are you going to talk to us about today in a nutshell?
I'm going to talk to you about how NASA is thinking about climate and how we are evolving our climate strategy.
Fabulous. The next 8 to 10 minutes are yours, Gavin. Thank you.
Thank you. Okay, let me get this up.
No worries. There might be a little bit. There we go. Okay. Great. I see that.
Okay. So thank you very much to the Copernicus hosts and everybody listening. And if you'll indulge me for 10 minutes, let me give you a quick overview of what NASA, a government agency, is doing with respect to climate and climate services. So the first thing you need to know about NASA is that we are predominantly an observational agency. We currently have 23 satellites in orbit or observing the Earth, either from the International Space Station or from Lagrange Point 1 or in low Earth orbit. And we measure things as broad as the changing gravity field of the Earth, the clouds, the radiation, the sea ice, the temperatures, the water vapor, the ozone, and just imagery of the surface, and have been doing so since the 1960s, and particularly since 1979. A background of the trends that we've seen over that time comes very, very strongly from the backbone of NASA observations that have been conducted over that time period. Let me give you a few examples. This is Landsat imagery that has been ongoing now for almost 40 years. This is imagery from the Columbia Glacier in Alaska, taken in 1989, and the continuity of this series of satellites allows us to see what that looks like this year. And so you can see in this situation, there's been a retreat of about 30 kilometers of the glacier, but we could have gone anywhere pretty much in the world to see this. So the Rockies, the Andes, the Himalayas, the Alps, all of them have seen very dramatic changes in their snow and ice cover. We're also tracking things that aren't so obvious, like the gravity of the Earth. And the gravity of the Earth changes because of mass changes, particularly in areas where there are large changes in the ice sheets. We're tracking the changes in the ice sheets using altimetry, but also gravity measurements. And they tell us that Antarctica, for instance, is currently losing about 150 gigatons a year of ice. And Greenland is losing even more ice every year. And you can see the time series that we have from that dating back to 2003. Again, pointing out that the long-term measurement of climate change is really informed and supported by the network of continuing satellites in space. One other example where we have historically worked very closely with the Europeans. Tobex Poseidon was a joint NASA-French mission. Centennial 6 is an ESA NASA operation. We are tracking the global mean sea level as it inexorably rises, and we understand why that is. So we're making the observations, we're also doing the analysis, and we're closing the budget on why things are changing. And we know that the global sea level is changing halfway because of the warming oceans, which are expanding the oceans, but then the changes in mass from the melting ice sheets and melting glaciers are contributing to this as well. So we understand these things, and we're also monitoring them. We use our information about the climate processes at work to build models, and without models we can't make projections. And so we take in information from space on land surface properties, topography, emission of various atmospheric components. We use the processes that we can observe with respect to convection or cloud formation or rainfall to build parameterizations for the climate models that embed all of this information. We use machine learning and artificial intelligence to take those models and calibrate them as best we can to the actual observed situations that we can see. And then we can evaluate those models. How well are they doing? Where are their errors? What are their projections looking like? And then we go back to the data and say, okay, well, where are their issues? Let's improve the data. Let's improve the parameterizations, and around we go. And that cycle is actually kind of nicely tuned to the cycle that Valerie was talking about with the IPCC reports, and these things kind of go in sync. But all of these models are heavy users of satellite data that is being taken from NASA or from European or Japanese satellites. But NASA is also an aeronautics research agency. The first A in NASA is aeronautics. And so we are at the forefront of building new technology and developing new technologies for global sustainable aircraft operations. That includes changes in airspace operations to reduce unnecessary fuel use, the development of new hybrid powertrains that are being tested, that the contracts are going out this summer, and and we'll be seeing the first hybrid airplanes come out of NASA research in 2023. And we're also developing designs for net zero flying using either hydrogen fuel cells or we have a demonstration plane, the X-57, which is an all-electric flight demonstrator, which you'll be hearing a lot more about in the future. And so all of these things, whether it's technology, fuel, or operations, all of these things are being informed directly by NASA research in aeronautics. We work continuously with different partners who are not just users of our data, but are co-producers of useful information, whether it's foundations, science institutes, New York City, or regional government or local government, or the C40 cities. All of these are using and helping create information from NASA data to inform the decisions that they need to make at whatever level they are at. But we understand that there is a future in climate services that is yet to be realized. In the US, there's a lot of duplication. There are a lot of different agencies who kind of work in this space, NOAA, Department of Energy, NASA. And one of the things that we're working towards, particularly with this new administration, is a more collective view of how this should work. Both in terms of exploring the hazards that localities and industries and groups and communities are suffering under, assessing what the risks there are, and then thinking about the options that are informed by the science that we're bringing in, both from space and locally. This is very much an evolving partnership across the agencies in the US, and I think what you will see in the next few years is a maturing of this effort for everybody. And of course, things that are being done by the US government are also available for anybody else around the world. I'll give you one link to finish with, toolkit.gov. Toolkit.climate.gov, where a lot of those tools are already being made available, and a lot of the data that you might need, whether it's local data, regional data, or data on connected issues such as land use change or air quality, can all be found. We are very excited to partner continuously with the ESA and the European Union on meeting the challenges of a changing climate. And we recognize that going forward, it's only going to be through a joint and collaborative effort that we're really going to be able to maximize the use of data and the use of data for making better decisions with respect to the climate. So thank you very much.
Thank you. Thank you very much. I just saw two of me there, which was fabulous. Now I see one of me. I think you might need to stop sharing. I think if speakers stop sharing after, then we can get back to both of us, because I do have a question for you. And thank you, so interesting there, really comprehensive. Very interested in when you were talking about the use of AI that calibrates, that recalibrates, because part of this is about the understanding, the tweaking, the understanding, the monitoring, the evolution, and also fascinating. And we're going to talk more in our last session, the future of climate services. You could say a bit too much duplication. The collective view is important, but how do you avoid the duplication? Now, right at the end there, you did, of course, say the value of working with various partners and with the EU. The obvious question for me, Gavin, is, of course, and particularly because we've got this new US administration, is, what do you think? Two things that the US can learn from C3S, and perhaps more widely, or three short ones, or perhaps more widely from the EU experience. Where do you find it particularly valuable, that exchange of learnings or practices?
Well, this has been funded, whereas in the US, something similar has not actually been funded. It's mostly being done by different groups at different levels, and so it has not been as coordinated. And so having central funding, having a coordinated view where all of the different countries, all of the different agencies are working together on one platform, that is something that the federal government is discussing, but it has not yet realized. And so I think that there's a lot to be gained by having individual groups kind of working towards one particular outcome, as opposed to independently different agencies doing their own different thing, which the US has, I think, a valid criticism of how the federal government works is that there are too many things all happening simultaneously, but they're not always as perfectly coordinated as they could be.
Okay, thank you. I can see even Carlo backstage kind of reacting also with the splendid. Oh no, you've got a bookshelf too, Gavin. Thank you. That's very useful and very interesting to hear that obviously the similarity. You talked about the fact that you do work with a plethora of partners, but interesting what you say there, perhaps it's being centrally funded and that would be more useful. There's some fair criticism there. Well, don't go away if you please, because I do have a couple more questions for you and I need to bring you back after we've heard from our next two speakers. But I thank you very, very much for your fabulously comprehensive keynote. Thank you. You can take a short breather. The first session, ladies and gentlemen, wouldn't be complete without our next two speakers. The first of these is a gentleman called Mauro Facchini. He's been with the European Commission since 2002, involved very much in space aspects, contributing specifically to the definition of the European space policy, leading on the EU space competence in the Lisbon Treaty. So he'd be a brilliant person to have next to you at a dinner party, I would say. And he's been actively involved in the development of Earth observation capacities. Anyway, to cut a long story short, he is leading the Copernicus unit at the Directorate General for Defence, Industry and Space. So Mauro, you've got an ample 5 minutes to share something very important with the audience, perhaps picking up from some of the things that Jean-Noël talked about at the start. What are you going to focus on, Mauro?
Yes, thank you very much, Katrina. Good afternoon. Can you hear me, first of all?
Yes.
Okay, very good. This is already a success, first one. So I think that today I have 5 minutes. I don't want to take much time from the excellent researchers and everyone that is speaking about the climate change service. My speech is mostly really to reassure everyone that the Copernicus Climate Change Service will continue, because this, I think, is something that is quite important for everyone. And I will start by thanking ECMWF and Italy at the same time for co-hosting this event today. Very important is I would like to acknowledge the excellent work that ECMWF has done with in the Copernicus in the last 7 years. I was there in 2014 at the end of the year with Jean-Noël and all the colleagues when we signed the agreement. We put the money into that, and I have to say that after 7 years we can say that it was a good value for money. We're speaking about several hundreds of millions of euros, so it's not peanuts, but I think the investment is really worth. I think that where we put the money is extremely important. Now we are not just happy to what we did in the past, but we want also to reassure everyone that we will continue in the future. So we will continue. We're moving into what is called Copernicus 2.0. And good news is that last week, the piece of legislation that is called the space program has been adopted. It's been, I think it was last Wednesday. What is concretely meaning is meaning that between 5 and a little bit more than 6 billion euros will be available for Copernicus in general for the next 7 years. So 6 billion, taking into account EU contribution, but also contribution from other countries like Norway, Iceland, UK, that are not part of the EU. So good news, because we can continue. And we are really at this moment in time negotiating with ECMWF the continuation of our cooperation, both in C3S and also on CAMS, so on the atmospheric composition monitoring. The negotiations are very good, I had no doubt about that. And we are targeting to sign the continuation of this cooperation, let's say towards the end of June or beginning of July at the latest, in order to ensure the continuation of this activity. It will not just be continuation. We have also to see how we can eventually evolve. So also do something more, because, for example, we'll have to ingest new satellite capacities. Sentinel-4, 5 will be flying. There will be CO2 monitoring that will be flying in the period 2025-2026. So a lot of new data that will have to be ingested and could also support the evolution of this service and C3S. So not just the continuation, but also looking into the evolution. And in this respect, again, we really look forward into the continuous cooperation with ECMWF. I would not like to take much time, but I would like to conclude on saying that this kind of events, because sometimes it's considered us in Brussels, we are in a kind of a bubble somewhere. So you see, I don't have books. I have something that is more flat behind me in some way, but I think, or dry. But I think that for us, participating in these meetings is really quite important, because we really taste where actually what we are doing, what we are fighting for, what is the final support into that. And for me, as a manager of Copernicus in general, so where I'm dealing with emergency aspects, environmental monitoring, security, and so on. So I'm proud to say that what I'm doing every day, I see where it's really going, and it's very important. And if I really link to the climate, I mean, I have children myself, and I'm worried about the planet, so where it's going, and about the planet I will let to my children as heritage. So I think that, and I hope that the bit of thing that I'm doing in this respect, and ECMWF is doing very well with all the researchers, can really help to provide a better planet for our future generations. Thank you.
Thank you very much. I like that. And when you talk about that and your children in the future, I'm just glad, Mauro, that you were able to turn up and give good news there. Because if you had turned up and given bad news about no continuation, then I don't think anybody would have been very happy, and you would have somehow been virtually assaulted. So I'm glad for you. So thank you so much for your brevity and for your upbeat nature, and for also emphasizing that, Kat, we actually need to do something more in this next phase. This is evolving. We've heard about it. And again, this is going to be very much a focus of our last panel on the last day. How do things need to evolve from the services point of view, from the policy point of view, and so on. But I thank you for your enthusiasm. I can let you take a seat backstage now, because I'm going to invite our last speaker of the session to join me. I can already see that there's a question come in for Gavin. So if you're looking at the chat, Gavin, I'll be able to pose that to you when I invite you back. So we cannot have this opening session without the director of the Copernicus Climate Change Service. He is Carlo Buontempo. So I'd like him to please join me on screen if he could. Hello, so delightful that you are here, and I think this is going to be a lovely way to finish these presentations, because it would be good to hear from you what you're particularly proud of, some of those key milestones, some of those key achievements and highlights. I did say we're looking to the future too in this event, but we really do need to focus on what you think is the particular unique selling point of C3S and what you deliver to users. So the floor is yours. Thank you. You'll need to share.
Thank you. This means that I am now allowed to share my screen, right? Is it working?
It is indeed.
Very
yes.
good. So, well, the first thing I would say is that we made it. It wasn't necessarily obvious when we started 6-7 years ago. But if I look back at the beginning of this journey, it really looks so close in many respects and so many far away at the same time. Personally, I think it's just mind-blowing how much we achieve and how much we learned over these last 6 years. Copernicus Climate Change Service is indeed one of the 6 thematic services of the Copernicus program, but is also one of the first organized attempts, in my opinion, to operationalize the generation, the curation, and distribution of climate data and information to society. I'm a physicist by training, and over the last 20 years or so, I mostly work on climate. This means that I very much enjoy discussing about almost any climate-related topics. But while some of you may share my enthusiasm for atmospheric convection or Ekman pumping or any other climate process, these are not the kind of information society is currently looking for at the moment. So if we look at this pandemic, this has made just more evident the ongoing transition towards data in the way our society deal with risk and opportunities. This is clearly happening also in the field of climate. If you think about infrastructure and building, for instance, if you think of the Eurocode, or the new emerging standard for climate adaptation, like the ISO 14090, or if you look at initiatives such as the climate-related financial disclosure, or even if we consider the systematic evaluation of climate risks associated with any development project, we can find a common thread. And this is that all require reliable and trustworthy data and information about the past, the present, and future climate. In a nutshell, the need for climate data and services now permeate most sector of society. And I guess many of us have one of those mobile phones. Hopefully, you're not looking at those at the moment, but in our pocket, and we use it every day. And in many senses, it revolutionized our life. But only a small minority of us is interested in the way the algorithms have been written to maximize battery life, or the relativistic correction that I use to process the GPS signal that is in this mobile phone. We are users of these tools, and we don't give a dime about the wonderful science or technology that goes into them. Up to a certain extent, and I will be happy to discuss with some of you later the limit of that. The same applies to climate. I feel we are at the dawn of the operationalization of climate service, and there is a long way to go still. But I like to think that C3S over the last 6 years played a role in such a process. When ECMWF took the responsibility of leading C3S, I was working at the Adley Center, and I was at first surprised by the news. Wasn't the scope of the service beyond the remit of the organization? In hindsight, I think this was a brave and wise decision. Even before being a center of excellence on weather and science, ECMWF is an operational center producing excellent weather forecasts day in, day out. Entrusting ECMWF with such a new responsibility was a way of highlighting the need for transformation in the provision of climate services into something more standardized, timely, and better tailored for a large public consumption. I would like to take the opportunity to thank each and every person who supported such a vision from the beginning. But in particular, I would like to thank General Trepot, Bernard Panty, and Dick D for allowing this impactful program to take off. Oops, too fast. You were saying, what am I proud of? What we've achieved during this first phase of the program that concludes this year, really. What is the aspect I'm mostly proud of? Well, I think the answer is that we established ourselves. We were not on the map. We were just the new kid on the block. And we went from 0 user to nearly 100,000 in the space of 3 years, with a growth rate that has not yet slowed down. So even when considering that a large part of that user base actually is a use base of the analysis product that pre-existed Copernicus, the remaining is still very remarkable. And the fact that one of the every 2 users nowadays is not a user of our reanalysis is a sign of that. As is a sign of success, the fact that we deliver roughly 1 petabyte of data every couple of weeks. So nearly 50 petabytes of data over the course of the last 3 years. I think, maybe it's me having a small horizon, but I think it's quite mind-blowing in terms of data size. But being operational actually means so much more than providing large volume of data in a timely fashion. It means having a user support with well-defined KPI in terms of response time and a solid user forum. It means having good up-to-date documentation and tutorials. It means having good training modules and education material. And this function had to step up their game immensely over the last few years. If we consider that we started with a handful of products, less than 20, and the catalog now counts more than nearly 100. But being operational also means to systematically provide quality attribute that user can look at when deciding the fitness for purpose of a specific data set to a specific application. Now, not everything was easy, not necessarily worked well the first time around. For example, it took us some time to find the right footing, especially in relation to our interface with society. We developed a large set of application and use cases spanning a wide range of sectors. This proven very valuable as an engagement and communication tool, but it also triggered a reflection on the real scalability of such an endeavor. if our final goal is to provide good quality, actionable data to society, our small team should not become the bottleneck. So if you look, you can go and explore our website, and you find many application and case studies. And over the years, C3S transformed itself into a real enabler supporting downstream tailoring and international, national, and regional level. The many small, medium, and large company, as well as public organizations that now develop value-added product on the back of C3S data, represent a tangible measure of this success. A few hours ago, for example, we released the European Climate Data Explorer, which allows the data from C3S to be used by the user of the European Environment Agency. To further support this downstream exploitation, we also established a user engagement function, which is now fully operational. But aside from sector-specific application, we have also a series of products of more general interest, such as the European State of the Climate Report. This is published every year, typically in April. And last year, 2020, was definitely a very interesting year for Europe climate-wise, and for the North Atlantic, for what it matters, with rather unusual temperature in the Siberian Arctic and a very active Atlantic cyclone season. When back in April, I wrote a message to thank all the people who contributed to this preparation of the European State of the Climate Report, I counted some 80 recipients to my email. This is a sign of how much this report has grown and how much it has become an effort shared across a vast community of scientists, researchers, communicators, and technical experts all over Europe, and in some cases farther afield. This new prominence of our activity was reflected in a significant visibility of C3S in national and international media outlets. Because being operational also means being visible and recognized by the general public. In the crowded landscape of Europe, it wasn't necessarily obvious for us to find a space to present our data on climate and our services. The multiplicity of tradition, of fora, languages, and interest is one of the richness of our continent. And this is true for climate data as it is true for food or drinks. But climate knows no border, we know. And the ability to build on the national expertise and generate information of a more general relevance, similar to what ECMWF has done for weather over the years, is definitely one of the assets of the program. And clearly, I mean, a bit like Gavin, observation as the starting point and the monitoring of what we do is critical. I focus so much on the monitoring also because our key product is the global reanalysis, which is by far the most popular product and provide a global reconstruction of the past weather hour by hour back to 1950s in any place of the planet. What you can see here on top is a reconstruction of the tropical cyclones, Florence, making landfall in September 2018 in the US. On the left is the old product, the ERA interim, and on the right is the reconstruction by ERA 5, the most recent product. And you can see that actually ERA 5, well, you cannot see here, but you have to trust me, provide a better reconstruction of the climate in that moment. What is at the bottom is a reconstruction of the global mean temperature anomaly, going back to 1950s, up to a few days ago. And this is really a tool that allows us to monitor, for instance, the warming of the troposphere that you see in red on the bottom right, and the cooling of the stratosphere above. But the other reason why observations are so important, because similarly to what Gavin was saying before, we are an observational program. Copernicus is a remote sensing program, as we heard from Mauro. And this is natural for us to start from a systematic observation of the climate system from satellite. We do it through the monitoring of the essential climate variables. These are a collection of 54 variables that the global climate observing system identify as being essential for monitoring the climate of our planet. The operationalization of ECV, essential climate variable, production and distribution is an activity that relies on a very large number of international organizations, university companies, which have developed the algorithm, reprocessed the data, document the work they have done, provided a quality check before passing the data for us to make available to the climate data store. At the moment, we have 22 of this variable, and we would like to expand this list in the next phase. And so it was very good news to hear what Mauro has had to say about the agreement and the future next few years.
You have about a minute,
I'm all set. I'm ready to finish. But to meet the new societal needs highlighted by the renewed ambition of the European Commission, I'm talking about the European Green Deal, which is essential for the program like ours also to look at the future. ECMWF service culture has came once more into our support. So if we look, for instance, our seasonal prediction, this builds on the experience that the center had on seasonal prediction. But C3S went beyond this and engaged with the producer of decadal projection on decadal prediction or multi-decadal projection, both global and at the regional level. And work
it's
with
okay,
them.
sorry, don't rush, Carl. I'm not sure whether people can see you in the light. It could be me who, there we go. I need to make sure you're back and not me. Bear with me a second, don't rush. I don't want to.
No, I'm just.
But we lost you for a second there.
Oh,
and
sorry.
I wanted to just see you. So the people, perhaps it's just me not seeing. As long as you can be seen and what you're presenting, that's great. Carry on,
Okay.
Sorry to just interrupt you.
That's okay. But what I was saying is that one of the aspects is the access to data, but the other important aspect is to engage with the modeling community and the underpinning data infrastructure to ensure that the data can be sliced and be post-processed on the fly without the need of moving large size of data across. There's also another point, and I close on this one, and it's the fact that some of the work that we have done over the last 6 years actually is work that would have been difficult to do by research institution. So I think about the work on standardization of data across thematic stream, like quality control, or tools to improve the traceability of the output back to its provenance. So these are typically activities that are essential for climate services, but they do not necessarily lead to a high-profile publication, and so often are on the margin of what is needed, or what is done by research. So the struggle for personalization of climate service provision has just begun. But I'm absolutely convinced that over the last few years, C3S managed to put some important stepping stone really to bridge the gap that existed between the provider of climate data and the societal users. So I can wrap up here. Thank you very much for your attention, and just in honor to our many member states, grazie, merci, danke, thank you.
Thank you. Go on, a few more, Carlo. Come on.
Well,
are you going to stop there? That's piffle.
Well, there are too many countries, and my language sorry about that.
Excuses. If you have stopped sharing, then great, I can see you. And what I really like there, you're absolutely right, Carlo, being operational, that was a good thing you said there, means being visible. And I really did catch that. And thank you so much for running us through some of the reasons why. I mean, I called it unique selling points, but I love the idea of what you're saying, standardization, the quality assurance, you're processing things on the fly, you're offering training, it really is fully operational. And so that was really, really helpful. Can I ask our two keynotes to come back, but as I do, I've got a quick question also for you, Carlo, which is the obvious one, but it needs to be a short answer because we've got two questions that have come in from our keynotes, and I've got a couple of pre-prepared questions. But what I'd like to ask you first, Carlo, is obviously if you had to say, Kat, the 3 key lessons from Copernicus 1 and how that's going to inform you as you go into the next phase in 3 cool sentences, what would they be?
Well, I think even for a matter of brevity, I can focus on one, which for me is probably the most important. And for me, the key lesson learned in Copernicus 1 is really the role of us with respect to the downstream segment. So in a sense, to support the transformation that we were talking about, that we heard the other speaker talk about, we need data, but that's not the only thing that is needed. And the decisions are typically made at very local level. They are specific to specific users and are much more difficult to mainstream. So I think there is a role for a central agency, a central program like ours to play. And it's very much on the data and the standardization and on the tools and on the industrial support, if you want. But there is also another role to be played by society. And we are really helping and supporting the downstream exploitation of the data we have. And I think I see that role emerging as being one of the lessons learned from the first phase. Oh, sorry, I don't hear you anymore.
I'm muted, that's me.
Right, okay. Well, it needs to happen at least once every teleconference.
Oh, more than once, trust me, it'll happen more than once. I don't want to create any possible interference when you're speaking. What I will just say for those who are less familiar with C3S, and when I was doing my research for moderating this, I mean, you gave some examples from your website there, but what I found particularly useful was indeed those case studies. When you think of the amount of different uses from the healthcare sector, the Heineken brewery, commodity traders, biodiversity University in Costa Rica. I mean, that is a really good picture. And as you said, very complex to understand the right data for whom in a timely fashion so that it is ultimately relevant and useful. It's all about user requirements. And we also heard Jean-Noël talk about that at the start. So Gavin and Valerie, there's a question for Gavin, which is coming from the chat, that trends seem horrifically irreversible. How does NASA see the role of new tech in this galloping problem called climate change? That's for you. And there was also a question for you, Valerie. Nod if you've already seen it. Did you see it? You did see it. Okay, the contribution of each continent, indeed. So Gavin, shall we come to you first? If you've got your mic off, then...
So, I mean, the trends that we've seen over the last few decades are being driven by human emissions and human activities. There's no question about that. And so, if you want the trends to change, then it's those human activities that need to change. They're not going to change on their own. The dominant trends are caused by the increases in greenhouse gases, carbon dioxide, CFCs, methane, nitrous oxides, and those are controllable. You know, we've seen that you know, over the last year, with responses to the COVID pandemic, that society can change in ways that reduce emissions and improve air quality. But for that to be sustainable, we need to do something different than just, you know, setting whole chunks of the economy into lockdown or of various sorts. So you know, those trends are driven by our emissions, and it's only by controlling those emissions that those trends will change.
So when we look at, you know, you talked obviously about that this has been a kind of there's been elements of this lockdown that's been a test bed in various areas, not least aviation, not least road transport, all sorts of other areas. But data versus information, I mean, you know, to increase societal action, and it could be anyone answering this, but it's got to be a 30-second answer, ladies and gents. What more needs to be done? I mean, how do you find that balance, and how do you stop the media fatigue at a societal level? Carlo, I think you unmuted yourself there.
Well, I guess part of the answer is linked with what I was saying before. For me, you know, you can tap in the existing narrative and engage with the general public, or you can transform the conversation completely by entering in a different dialogue. And it's about, you know, it's about economics, it's about impact, it's about decisions. And there is not really fatigue. Actually, there is a desire to engage. I mean, we see it everywhere. The example I was making myself, the infrastructure sector, and we will hear in the GA later on how they are adapting and what they have for climate information. That's a completely different conversation. So it's not about polar bears. So I often make this joke that is, I give polar bear free talks about climate.
Oh, don't. You're beginning to sound like Boris Johnson in his bunny hugging. You're making me go.
No. I definitely not sound like Boris Johnson. But what I'm saying here is really the connection with the economy, with the decision, I think is where you're changing the narrative, where you change the equation completely.
Yeah, I think so. And I think particularly you see that in Europe, where the society, where you've got the social, the environmental and the economic coming together, and also seeing within the context of the European Green Deal, the way out of that, linking all of those so that they go together hand in hand. So thank you for that. Valerie, yes, what's the contribution of each continent towards the realization of quality and accessible climate data and membership of any institutions from these continents working towards climate monitoring under IPCC?
Before addressing that question, I just want to flag one thing. In addition to data and information, I think you can engage with people when you stress the importance of choices. And we flagged how much every fraction of additional warming matters in recent IPCC reports, which shows the information related to the near term. And in the work we did on the Ocean Cryosphere report, we flagged the importance of climate information in the geographies where you live. so that you can deliberate on what you choose to do locally. And finally, in the land report, we touched aspects that are key for agriculture, food, and food is an important cultural aspect. And this, I think, is important to engage with what matters to people. And I share what was said, that many people want to understand and are ready to engage much further. And my experience with the agricultural sector recently is really impressive on that, because they are on the forefront of dealing with a changing climate. And regarding the question about continents, I cannot make a comparison of the contributions of each continent in the internationally coordinated efforts for climate monitoring. And this is done under the auspices of the World Climate Research Programme, the Global Climate Observing System, the World Meteorological Organization. Within the IPCC, what we see is peer review publications, the ability of scientists from different continents to engage as authors. And I would like to flag that there are still a number of barriers. The availability of data, not monitoring, but the availability of data in some places in the earth, especially in Africa. The availability of attribution studies, where you look at what has happened and you decipher, is it natural variability? Is it driven by human influence on the climate system affecting specific events where you live? And there are gaps, especially in developing countries, regarding these attribution studies. And finally, I really see a potential, because the Working Group 1 report had an impressive contributions from a bright generation of African scientists. It's really impressive what they are ready to deliver. However, there is a need to support them so that they develop their own research agenda, not driven by funders like developed countries, but by themselves. Yeah. And to support centers of excellence, because the push from their governments is to develop more applied research to address societal needs. And we have seen from Copernicus Climate Services the added value of linking climate services and connecting to user needs with high-level basic research. And I really think that there's a potential now to really sharpen and strengthen that, especially in Africa.
Thank you. Thank you very much. I have two further questions. I'm going to be very rapid here so that I can close this and give people a chance to go to the poster session and just get some fresh air and have a bit of a break before our second and final session of this first day. As you may or may not know, good speakers, I think Carlo knows, the gauntlet was thrown to participants before this event. Say, if you have a question, send in your questions, and a lot came in which were curated. And there was a question that came in: will we be able to best describe climate future evolution by means of more climate data, or have we kind of arrived at the peak now of detail? I mean, we've already been talking about how things to evolve. Carlo, did you want to come in on this?
Well, I think there are two answers to that question. There is the answer of the climate scientist, and that answer is, well, no, there is a lot that we don't know, and we need much more research, and there is plenty of fascinating stuff. And it's true, there are many things, but we have, we genuinely need more research. But there is also the other answer, and it's more on the service component. And there is that we have a lot of information already, and so we shouldn't shy, behind the fact that there is something we don't yet know, and not take decision. The information we have is sufficient to trigger adaptation, to trigger decision making, to inform policies, and so we should use it to that end. But clearly, there is science underneath, and science is always moving, and there are plenty of things we still need to understand better.
Thank you very much. And maybe perhaps Gavin can come in. I'll put this last one to you. And maybe also somehow my slight clumsy question to Jean-Noël at the start when I talked about science being so much in the spotlight. And I think what I was trying to suggest is a little bit, Gavin, where you said sometimes there's duplication, there needs to be a more collective effort, particularly with a topic that is so much in the public eye. But let's just having a look at the traceability, the trust. I think we had the use of the word trust from one of our speakers. How do you mainstream that climate information without compromising on that traceability, that transparency, to make sure that those policy decisions that are taken really are based on that good quality data, that science?
Right. Well, one of the ways to do that is to have an open data policy. So, for instance, all NASA data is open and public domain. Anybody can do anything with it that they want. It isn't always the easiest to manipulate, and that's something that we're working towards. But for instance, one of the projects that we work with tracks global temperatures, back from the 19th century. To today, that's done. All the data sets are public domain. All the code is public domain. All the history of the code is public domain. And so, people still don't like the answers that it gives. But really, when you're as transparent as that, those kinds of complaints really don't have very much traction. And so, as we move forward to a kind of multipolar world in terms of satellite observations, one of the things that we really need to be pushing towards is open and conformable data standards, so that we can build long-term records that use a data series from multiple instruments on multiple platforms from multiple agencies in a way that gives us the best and most comprehensive view of the state of the planet.
Thank you very much. And going back to what was it Jean-Noël had said, that kind of MRI, the continuous MRI of the planet there, which I really, really like that image. And you've kind of brought it back again. I wish I could ask you more questions. I cannot, good people. You've been fabulous. But we do need to bring this to a close. And I loved, Valerie, what you brought in there when you were saying the ways in which you are even making, and I'm not suggesting for a minute this is off the agenda, but you've got to make it meaningful for people, have you not? So you were saying, looking at what's going on in your region so that you feel that you can actually make a difference. And it's not just the policymakers who sometimes people can be very frustrated with. So I thank you for bringing that in there at the last minute. So a very big thank you to all of you, our audience, for staying tuned, to all of the wonderful speakers in this opening session, not least Carlo, Gavin and Valerie, who have been with me until the end. I do realise that we barely scratched the surface of the content of your considerable brains. All of you, don't forget the presentations can be accessible on Swapcard until the 4th of June and on the C3S website, and we'll ask you to complete an evaluation form too. Don't forget now, you've got 25-minute break. There's a poster session, it's live. You can find out all about C3S, what it's doing in a variety of different ways through a variety of materials. You can talk to people. You can book meetings for tomorrow morning. You can even go and visit some booth owners in the marketplace and set up some meetings too there. Whatever you choose, please don't go away for good. Don't disconnect, because at what time? 16:30, just before CEST, we are back here to talk about the first in our various thematic sessions, climate impact assessment and adaptation. We're going to explore how C3S can respond to the specific needs of the adaptation community to deliver, there's that word again, trusted climate impact indicators that can be used in monitoring and reporting. And we're going to hear from all sorts of different stakeholders there to give you a comprehensive view. So don't go away for too long. Thank you, Carlo, Gavin, Valerie. Thanks to all my speakers, and see you all shortly. Bye-bye.
When we talk about operational production, our minds naturally go to the weather forecasting. These are based on the routine production of model output and the curation of the data provision to the users. But now that our society so crucially depends on the data provision, from the health sector to transport, from tourism to insurance, we need to do much more than just generating data. Also because this data comes in incredibly large volume, petabyte and petabyte of data. Operational climate service means generating the data, curating its broadcast and distribution to users, but also ensuring that this comes with ancillary information about its quality that is enriched by good and operational user support, training, and additional functions.
The Climate Data Store is an online, open and free service which provides access to a wide range of climate data, along with a toolbox which empowers users to do their own analysis and visualization using our cloud infrastructure to process large volumes of data. Our toolbox offers a comprehensive suite of quality assured tools, including software for developing user interfaces and interactive visualizations which transform data into user-friendly web applications. So here you can see our catalogue of published datasets and applications, and here's a quick example of the kind of application that can be developed with our tools. In this example, we have ERA 5 reanalysis retrieved from the C3S catalogue and averaged over 40 years. And we've put this in an interactive map, which we can use to click on or search for a city to discover a range of local climate statistics at the chosen location, displayed with some nice interactive visualizations. And one of the most powerful things about the toolbox is you can click on the source code of applications to explore the toolbox code behind each application, and you can copy this into your own personal workspace to do your own data exploration and develop your own applications. And you can search Copernicus CDS to get started.
The Arctic is really being transformed by climate change. It is the part of our planet that has warmed most rapidly in recent decades. And this is having a dramatic impact on all components of the cryosphere: the sea ice, the snow cover, permafrost, the Greenland ice sheets. All these changes make the monitoring of the Arctic an essential part of the mission of the Copernicus Climate Change Service. One reason this is essential is that the Arctic plays a key role in our global climate system. What's happening in the Arctic has impacts well beyond the Arctic region itself. Another reason is that these large climate changes don't just affect the physical Arctic environment. They have ecological, social, economic, geopolitical implications as well. So if we want to plan for and adapt to a warmer world, we really need to know and understand precisely how the Arctic is changing. Through its Climate Data Store, C3S provides a range of climate data sets that are freely accessible to everyone and can help achieve this goal.
So we want to get an understanding of the climate system and how it's changing. And one way to do that is to use observations. So we collect observations at C3S from in situ. So that means to measure on location, for instance, at the weather station or at the tail of an airplane. Or we use measurements from space, so using satellites to get a global view of the climate. Then we also use weather models to combine all these observations into one large estimate. So we can look at things like temperature, for instance, or we can look at sea ice. But we also combine these different measurements into our monitoring products. So for instance, on a monthly timescale, we produce our monthly climate bulletin, but on a yearly timescale, we'd also produce the European State of the Climate, where we look at the past year and on long-term trends and how the climate is changing in Europe.
Usable information is based on reliable and quality data, and it is based on traceable and replicable operations performed on the data. If you need to answer questions such as, will next winter conditions influence the energy demand and production? Or is the crop productivity this current season being the same as in the last years? Or is it larger? Or which areas are the best suited for building and operating a wind farm? To answer those questions, you need the right data, and you need the right interpretation of the data, including quantifying the uncertainty and evaluating the skills of your interpretation. So how we do it? We built a lot of flexible and interactive applications on the data that are relevant in many climate-sensitive sectors. We support data fluency through proof of concept, simple and robust. We guarantee continuation, full support, and accessibility. We share successful stories to demonstrate working solutions. And all the information is free, it is open access, it is reusable and quality controlled.
Climate change is upon us. We humans feel the impact, but do you know that actually all life forms on Earth are affected? Climatic changes disturb habitats and force the species that live in there to move or adapt. Those that cannot adapt are prone to extinction. So climate change threatens biodiversity, the rich variety of life on Earth, which is vital to our human well-being. We recently developed the C3S Global Biodiversity Service, which offers bioclimatic indicators. The service helps scientists, policymakers, and businesses to reduce global biodiversity loss now and in the future. Indicators that inform about sea ice concentration, wind speed, wind direction, for example, help to assess the impact and draft conservation plans for Baltic seals. They give birth on sea ice and may see their pups at risk of predators if they have to deliver on land. Other indicators about future aridity, for example, inform about which tree species are climate resilient to reforestate tropical land in Central Africa.
Trusting data and the products derived from it is of key importance for users. The trustworthiness of a service depends on its capacity to guarantee that what is provided is free from obvious errors, well documented, according to well-known standards. The uncertainties are appropriately characterized and provides exhaustive information about the service limitations, very much like what appears in the information slip of any medication purchased at a pharmacy. C3S has built an operational quality assurance framework to ensure that both data and derived products are quality controlled. This framework, which covers essential aspects of any service, has been put into practice, and the resulting information is now available in the Climate Data Store. The evaluation and quality control information for the data available in the Climate Data Store includes independent assessments that are systematically carried out by third parties to confirm the technical and scientific quality standards of all the data provided and of the products that can be generated from it. The evaluation and quality control function is also aiming at guiding the users in their decisions to select the right data for their needs. The delivery of transparent and traceable information contributes to making C3S a policy-relevant climate service.
In the context of climate change, expansion of vector habitats in the distribution ranges of vector-borne pathogens such as malaria, dengue fever, and yellow fever is projected. Our project aims to develop tools founded on C3S datasets to facilitate risk assessment for habitat suitability and vector abundance, and to offer guidance for vector management. Using C3S climate and meteorological data at the most critical locations to perform reliable risk assessment will contribute to reducing the global burden of vector-borne disease. The vector demo case is provided as a service to scientific experts, decision and policymakers, as well as to the general public through identified citizen scientist initiatives. Already, more than 20 unique stakeholders and user communities from multiple countries are using the demo case and are providing feedback.
Well, in order to monitor climate change, it is also important to know about the climate in the past to have a reference. For that, you need as many historical observations as possible. Now, these are scattered around the globe, and you have also less of them when you go back in time. That's quite complicated. So in order to help users, C3S has glued its observations together in easy-to-use maps without gaps. In the method that we use, called climate reanalysis, that glue is based on a modern weather model. As a result, climate reanalysis delivers hourly snapshots of the global weather and climate for decades in the past. Our climate reanalysis products are used by many. If you want to know more about reanalysis and what C3S provides, you can go to climate.copernicus.eu/climate-reanalysis or just browse for C3S reanalysis.
Historical observations are important to monitor and to understand changes in the Earth system. It gives us the opportunity to compare the climate of today, which we estimate from the comprehensive modern observing system, with the climate of the past, where observations are generally much more sparse in time and in space. We use these observations in reanalysis, for example, where we analyse and reconstruct the climate over multi-decadal timescales. Often, these observations are only available in their original form, so as paper records or as paper or magnetic tape. And these media are prone to degrade in time, so there's a real risk that we lose this valuable information in the past. In the case of satellite data records, for the early satellite missions, many of the experts have retired, and sometimes key documentation is lost. The Copernicus Climate Change Service is involved in recovering and rescuing this data so that we preserve it and make it useful well into the future. If you're interested in discovering more about this activity, visit the Data Rescue portal on the C3S website.
Marine spatial planning is the set of policy mechanisms that determine how marine space is shared by people and businesses from different sectors. Marine species and habitats have a natural capital that underpin the activities of many of these sectors. However, under climate change, marine habitats and species distributions are changing. This poses a widely recognized challenge for the delivery of effective and sustainable marine spatial planning. In the C3S Marine Coastal and Fisheries Project, we worked with stakeholders on the production of a set of climate impact indicators for European regional seas. These include predictions for physical variables such as ocean temperature and the location of ocean fronts, as well as biological variables, including fish abundances. The data were incorporated into the climate data store and made publicly accessible to end users. In the context of marine spatial planning, we also developed and applied a set of tools to help identify whether ecosystems underpinning different marine sectors are predicted to be sensitive to climate change and where they are predicted to be resilient. Together, the data and tools can assist with the development of adaptation strategies for marine spatial planning. One of the major benefits of this service is that marine policymakers now have free access to data, tools, and documentation that would otherwise be difficult to obtain and use.
Satellite-based climate data records allow systematic global observations and regional comparisons. We monitor atmospheric composition. Greenhouse gases, increasing since pre-industrial times, drive global warming. Aerosol particles influencing clouds counteract, mostly cooling, with regional variations of their type and trends. Ozone has an overall warming effect, with trends varying over altitudes and regions. We provide quality-assured, consistent satellite-based data records over the last few decades, so that users can nudge their models to reality, to quantify sources and sinks, to better understand the balance of cooling and warming, and to monitor trends in different regions and altitudes, all for better climate predictions.
Agriculture in Kenya is very vulnerable to climate change. Fortunately, there are many programs supporting farmers, but are the measures they are implementing actually climate smart? For that, you need to know how the climate is changing, and that's where our demo case comes in. To help farmers to adapt, we developed a set of C3S-based tools that allow users to generate crop-specific indicators. These indicators are tailored in terms of temporal and spatial resolution using the power of the Copernicus toolbox. To reach out to farmers, we work together with extension workers and county Met Office in the 2 counties of Kenya. A story map visualizes how the application can be used to generate easy-to-understand interactive maps and graphs. Using the tools, agricultural extension workers will now be able to make better informed decisions about adaptation. We continue building capacity with the local university and the Met Office on how to generate tailored results for different types of cropping, and we hope to extend the Climate Atlas to other regions in Kenya as well.
In situ observations are essential for monitoring the climate and have a role in validating other datasets. They are collected using instruments at the Earth's surface or using mobile platforms such as drones, balloons, and aircrafts. They are also a primary source of information for atmospheric reanalysis. We can distinguish between baseline and reference observations. The first offers more intensive sampling at a large number of stations globally, but providing less information on the collected measurements. The latter, providing the highest quality traceable observations at a smaller number of stations, but with quantified uncertainties. Uncertainties are a key part of any measurement. Ensuring traceability in our measurements means that we understand all of the dependencies involved in making a measurement. We can therefore have confidence in the measurements and in the decisions we make based on them. This important aspect is a focus for reference measurements.
Our human health is affected by extreme heat, by diseases, by pollen, and those effects are even intensified with climate change. We suffer from more frequent and more intense heat waves, with increasing deaths as a consequence. Climate projection data can help with designing adaptation plans for heat warnings. During a hot day, we can feel in the city higher temperatures in an area with lots of buildings compared to an area with a green park. Those large differences in temperature, they are not well resolved by climate reanalysis models. So we need climate data at the scale of the local urban environment. And this is extremely helpful for local authorities to plan adaptation measures to reduce the health effects in a city. C3S meets the needs of the health sector by providing an operational setting with the latest climate information that is readily available. It also provides climate information for the next season. And this is really helpful for people suffering from allergenic pollen, so they know in advance when the pollen season is going to start. And then they can plan their actions like taking medication. Finally, C3S provides climate information for the far future.
Forestry conditions are changing. Winters get shorter, snow depths vary, frozen soil is less abundant. A few difficult years have alerted the forestry industry in Finland to get better informed. Basically, the interest for local climate information and more precisely formulated weather forecasts has increased significantly. In the process, the potential for long seasonal forecasts has been raised, and the use cases for these become also clear. Combining static, high-resolution trafficability maps with bias-adjusted C3S seasonal forecasts, using the ERA5 land reanalysis to do so, is informing users both on very local climate conditions and a bit of predictability further into the future. Harvester seasons has revealed new opportunities to organize cutting for a much longer time ahead. It leads overall to improved efficiency, and this especially has been interesting, the wood procurement for the former pulp, now bioeconomy big factories.
In C3S, we systematically collect requirements from our users via workshops, surveys, or by looking at the help desk conversations, for example. These requirements are then being stored in the database that we call the URDB. We carefully analyze these requirements and implement them wherever feasible, in the short term or in the longer term. This also depends on the popularity of a requirement. For example, many users have asked for climate data that goes even further back in time. So we added what we call the ERA 5 back extension to cover the years from 1980 all the way back to 1950. We also extended the regional projections beyond Europe that was based on user requirements. And we also constantly update documentation to support users. We guide them how to solve their problems with the toolbox, for example.
To help C3S users, we invite them on a journey, what we call the user support journey, which is a pathway guiding users towards self-help facilities. It starts with a Copernicus knowledge base. Our knowledge base contains a continuously growing collection of quality control documentation and guidelines, reviewed, checked by experts, and updated regularly. Then we have the Copernicus User Forum, an active platform for users to exchange, share, and learn from the experience of others. Our user forum contains all sorts of tips and good-to-know items well worth a visit. The user forum is also the place to watch for the latest news on the CDS infrastructure, datasets, and applications. And if you wish, you can even receive email notifications as soon as new announcements are posted. Rather useful. Both the knowledge base and the user forum are conveniently integrated in our secure inquiry web portal, where you can reach out to us for any question remaining unanswered, or simply to send your user requirements and your feedback to us. Remember that C3S is user-driven, so we want to hear from you. But why stop here when we can bring self-help yet to a new level? Watch out this summer for the launch of our new virtual assistant on the Climate Data Store. And keep in mind that all of this is free.
The Copernicus User Learning Services contract has demonstrated that a training program can be effective to increase confidence in the use of the Copernicus Climate Data Store and Toolbox. In particular, our training program appeared to be useful to help a wide range of users to access climate data and to make sense of climate data. Moreover, participants put forward that our training program was very helpful to learn how to develop target group-specific climate services. From our experience with the delivery of 30 training events all over Europe, we would like to highlight our major lessons learned. Our major lesson learned is related to the need to differentiate between different users of the CDS. Because a training for climate data expert is quite different from a training for climate adaptation professionals. For Copernicus 2, therefore, we strongly recommend to deliver target group specific training activities, not only sector or location specific, but also acknowledging different levels of knowledge and skills. Thank you very much for listening.
An important element of the Copernicus Climate Change Service is training and knowledge transfer. As an operational service, it is essential to provide guidance to our existing and new users to equip them with the necessary skills needed to make the most of our products and services, and to encourage use of best practices. Our training program caters to a wide variety of user types and application domains. We offer e-learning material, including interactive lessons, videos, and Jupyter Notebook tutorials, all freely available and hosted in an online platform. We organize dedicated courses to provide in-depth training by qualified instructors to target user groups from all our member states and beyond. These courses include face-to-face, online, and blended trainings and follow a train-the-trainers approach to scale our efforts. To achieve maximum impact with our available resources, we closely collaborate with other organizations in joint training activities, including massive open online courses, webinars, and training events. We also maintain flexibility to rapidly respond to evolving needs for training and to take advantage of opportunities for collaboration as they may arise.
Okay, in that case, I need to go out and come in again. Sorry.
Okay, no worries. I take note. Good afternoon again to our virtual audience and to our next set of fabulous speakers. Welcome back, or perhaps welcome for the first time to day one of the C3S Conference and General Assembly, which is organised by the Copernicus Climate Change Service with the support of co-hosts, the Italian Copernicus National User Forum. My name is Katrina Sickle. I have the great privilege of navigating us all through this epic 3-day extravaganza. So we've just enjoyed a very content-rich opening session, and we laid out some of the challenges already and some of the highlights of delivering climate services. We had a look at the IPCC report, we had the perspective from NASA, we heard from the European Commission. The good news that the next phase for C3S is definitely in the running. There's no question about that. So we got things off with a bang. Now we're going to focus in on the first of several thematic sessions, this one on climate impact assessment and adaptation. And again, with 6 fabulous speakers, I'm going to explore how the Copernicus Climate Change Service can respond to the particular needs of the adaptation community to deliver what we have established is trusted climate impact indicators that can be used in monitoring and reporting. Don't forget, ladies and gentlemen, if you have a question, a sort of a general one, stick it in the chat. You just need to go into the agenda and click on the live discussion. If it's something generic, stick it in the chat. If it's something for the speakers, then that will be curated by the organisers, sent to me, because I'm in Zoom, and I can pose it to the speakers and they can also have a look at what's coming in. And also in that live discussion, you can take part in polls. So that's very important. All the rest of the stuff, you need to have a bit of a nosy around the platform because there's so many opportunities to meet people, to network, to set up meetings, and to ask questions in the booths at the virtual marketplace. But why don't we try and test the poll function again? Only because I was so useless at it the first time. And while I'm asking you to do that, don't forget C3S21 is the hashtag. That's where you can put your brilliant gems of wisdom out into the Twitter sphere. So can we just have a look? Does C3S need to communicate climate science more? That's the poll that I wouldn't mind if you could just get a little bit busy. Let me remind our lovely speakers with me in Zoom that there is a bit of a lag with swap cards, so I just have to wait for a moment. Does C3S need to communicate climate science more? We talked about visibility. We heard about that from Carlo in the opening session. Yes, no, but that's not the core function of C3S. So I'm going to, I'm not allowed in mine to put that in. So there we go. Thank you so much for posting that in. Yes, 78% say yes, it does need to communicate climate science more. And 22% saying, no, that's not the core function of C3S. And who knows, in the chat, if you responded to either of those, you might want to stick your opinions in there because it could be helpful for a bit more data gathering for the organisers of this event. So who are our speakers in this second session of 6? Let's have a look. If we can bring up a plate with the speakers, that would be most helpful. And then everybody can have a view of what is on offer in this 90-minute session. As always, we will start now going forwards with a keynote, and then we will hear a series of dynamic interventions from across the diverse stakeholder ecosystem. So thank you for that. We can remove that slide now. And I'm going to ask our first speaker to join me. She is head of the Research Department 3, which is called Transformation Pathways at the Potsdam Institute for Climate Data Research. And she's leading an area called Pathways Specific Climate Risks. She's also IPCC lead author for Chapter 16 on key risks across sectors and regions in the 6th assessment report of Working Group 2. That's just the tip of the iceberg. Here we are, Katja Friele. So a very warm welcome to you. You can switch your mic on now. And I'm going to disappear momentarily. I will pop back, but what you need to do is, of course, to share your screen if you have a presentation. There we go. I'll wait there. I can see it. So that's very, very good news. And I can give you the floor to present for around 8 to 10 minutes. Thank you so much. The floor is yours.
Okay, thank you. For this presentation, I was actually asked to address the question, are impact models assessments suitable to inform decisions? And well, it nearly became a very short presentation, basically saying, well, yes, no doubt they are somehow, because they are simply the best tools we have to translate the best information about climate change, for example, from CMAP or Cordex, and plausible assumptions about future socioeconomic impacts into indicators such as crop yields, water scarcity, damages induced by extreme events, or changes in malaria transmission periods. All these indicators that tell us much more about the risks for society than the pure climate change. So simple information about temperature and precipitation changes. And these impact models actually represent our best knowledge about how a human or natural system respond to climate change. So for sure, they have to be asked. But on the other hand, these models are not perfect, of course. So we have to be very careful what type of decision we want to base on them. And to get a better understanding of their power, we have to test them, for example, under historical conditions. And that needs the best information about historical climate, as for example, from the new ERA 5 product. But it also needs the best information about the socioeconomic drivers, such as land use changes, changes in growing season, other adjustments of agriculture management or water management. And all these drivers actually often have a dominant role on the impact indicators we are interested in, and we can't ignore it. And the better we get on the climate side, the more the missing information maybe about these socioeconomic drivers become a limiting factor in the entire task of model evaluation. And let me just give you an example. So when we tried to build a model for flood-induced damages, we started from observed weather, used it as input for hydrological models, and let them provide the information about the runoff. That was then translated by another process-based model into flooded areas for the historical period. And then we simply combined this information about the flooded areas with historical information about asset distributions and calculated the potential damage, simply assuming that all the assets in a flooded areas are lost, completely lost. And this potential damage is then, of course, too high, so it doesn't represent the actual damage. And to get an idea of the, or better representation of the realistic damages, we calculated the vulnerability factor as the quotient between the reported and our simulated potential damages. As you can see here, the annual quotients in the red dots, and we used a smooth representation of this vulnerability factor you can see here in the black line. And this is simply used to scale the potential damages to get a more realistic representation of the actual damage. And this model is somehow quite coarse, so it only uses global hydrological models that were not calibrated, and our representation of the asset distribution is also quite coarse, just based on a simple downscaling of national GDP information by population or night light intensities. So we were not too optimistic that that model could actually reproduce a lot of the historic damages, but we were somehow surprised. It is not too bad in some regions, at least. You can see here on the left-hand side. So you can see the black line, that's the reported damages, and the purple line, the simulated damages. And in some regions, the model is quite good, explaining more than 60% of the observed variance. But in other regions, it's quite bad, explaining less than 20% of the observed variance. And it's still not clear why it is, so where these differences come from. But what created some hope is, I think, that are, of course, these plots on the left-hand side. So it creates the hope that the basic physical process representation in the hydrological model is maybe not too bad, and the basic concept of the model seems to work. Maybe these discrepancies between observed and simulated damages maybe come from a missing representation of protection standards or asset distributions or uncertainties in the reported damages. We can't answer this question, but at the moment, I would say there's some hope that the actual hydrological models work quite well. And let me give you another example where we got a little bit closer to an understanding where these discrepancies between modeled and simulated impact indicators come from. And this is a crop model where that was tested for its ability to reproduce observed maize yields from the FAO. And at the left-hand side, you can see the explained variances of the annual yield fluctuations. And on the right-hand side, the model's ability to reproduce the observed effects of heat waves. So the gray line here on the right-hand side is the observed response to heat waves. That is simply calculated as the average across all normalized national yields in the year of a heat wave in the center, and the 3 years before and the 3 years after. And what you can see that is that the basic version of the model that is, well, it's not completely out of order, I would say, but it's not too good in explaining what is observed. And it seems to underestimate the effect of heat waves, for example. But we were somehow wondering, is this actually really a missing process in the model? Is the model not sensitive enough to heat, or does the maize in the model actually doesn't feel the heat because we have the representation of the growing seasons in the model is not correct? And that's why we thought about another version of the model where the growing seasons are better constrained by observed data. And unfortunately, there's not so much information about growing seasons, and it's not temporarily resolved. But for the year 2000, there's a kind of snapshot of the around year 2000 growing seasons. And we used that to constrain the growing seasons in the model. And actually what you can see here is the explained variance of the new model version and its response to heat. And you can see that it's actually much better than the original model. So in this case, much of the discrepancy between observations and simulations seems to be due to the missing information about the direct human influence and the human decisions about the growing seasons. And with this, I'm already at the end of my talk, and it was only 2 examples, but I hope, and there are more, it's just not, there's just not enough time to show them. And I hope that I could convince you that this information about the direct human influences could be really helpful. And that's not just for model evaluation, as I've shown here, but also for future projections, because it would help to let all the impact simulations start from a situation that is really close to our present day situation. And that could really increase the relevance of, the relevance of the impact simulation as a climate service very much from my point of view. Thank you.
And thank you so much. So you did start by answering this very direct question, and you sort of said, well, super important, but not perfect, because they're not, for example, taking into account this human interaction. You've got literally 30 seconds. Just talk to us. I mean, you need to stop sharing your screen, and then I can share the streaming screen with you, if that's right. Yeah, we have to do this kind of ridiculous thing when we're talking online. Anything else that you would say, Kat, if I did have my 30 seconds? You said I didn't have time to give another example of, you know.
No, I think the current models, they have, of course, a representation of these direct human influences, but this representation is often limited by simply what we know about the historical period. So I think we could gain so much if we could, for example, get better information about growing seasons from satellite data and bring it into a format that can be used by crop models, for example. I'm really quite excited that something like that may become possible based on maybe artificial intelligence methods using the satellite images and provide.
Thank you, because just before I lose you, Katja, I was going to ask exactly that. We heard there at the beginning from Gavin, he was talking about this, how AI is used to calibrate, how to learn, to make adjustments. So that's, I was going to ask you, to what extent does that come in when you're talking modeling there? And
I think it would be great to use it simply to label the satellite images, so that you know, well, this is really this kind of forest in the image, or here actually the grow. You can see that before it was somehow an empty field, and now there's maize or something, so that you can somehow estimate the growing seasons from the satellite data and label what the satellite sees. I think that will be extremely helpful in the future.
Okay, thank you very, very much. As I said, don't disconnect. You can just relax backstage momentarily, because I'm going to ask you to come back at the end. As I said, ladies and gentlemen, if you have a question, please say for whom it is, to whom it is addressed. Keep it super, super short, and I'll try and pose a handful of those to our speakers when I've given everybody a chance to present. So the next of our further 5 speakers is a senior climate scientist for C3S at the European Centre for Medium Range Weather Forecast, and her name is Freya Vamborg. So I can invite her to come and join me. I see 2 of myself, Freya, and not one of you. I don't know what you see in the streaming, but at least while they sort that out, there you are, you're there. God, I was about to say, God, don't make me present, because as far as I understand, if I haven't got this wrong, you are going to share with our audience how to use the data on impacts to support adaptation, which is our focus at EU, national and local level. And I think you're looking at 2 systems or 2 sectors, human health and ecosystems. Is that right?
No, so I will be focusing mainly on climate monitoring.
Okay.
So I think one of my colleagues down the line, so to say, will be.
So that's just me giving me assigning you something, or assigning myself if you hadn't been there. So we'll wait for that. Forgive me. Well, then let me come to you and say, talk about what is the main focus of your presentation.
So I will talk about C3S climate monitoring. So one of the little boxes in Katja's presentation before. So kind of one of the links in this long chain of things that are needed in the kind of in moving towards adaptation.
Thank you. So let me give you some time to share, and then I will disappear, and I will listen and pop back at the end. Thank you. The next 5 minutes are yours.
Thank you. So I will actually start in my garden here in Reading, in the UK, and this is mainly because it's something my friend reminded me of. You know, when they say nicely, tells you this is what a day was like a year ago or several years ago. And it kind of links back with the presentation we saw before. So in my garden on the left this year, you can see some pink flowers, and they usually, last year, some pink flowers, and they usually come after these blue flowers by about 3 or 4 weeks. And these pictures were taken on the same day in 2 different years. So you can see that clearly there was some differences driving the growth in my garden. And I happen to know, because we do monitoring, that last year was relatively warm and sunny, whereas this year it's been relatively cold in the UK and large parts of Western Europe. So what I'm going to talk about for the rest of the presentation is the climate monitoring we do, but I also want to kind of reflect back on what was said in the presentation before, that the climate drivers are one part of this. I happen to know that last year, not only was it warmer and sunnier, but I also put some water in my garden because it was necessary already at the beginning of May, whereas this year is very much not necessary. So if we kind of switch to the climate monitoring pictures we see again on the left, 2020, relatively warm April for last year, if we compare to what we call our reference period of 1991 to 2020, whereas this year, all across Europe, it's been relatively cold, not only in the UK, but across much of the continent. And what I want to point out with this is that even though we know, as we can see from this figure, that temperatures are increasing in Europe, if you particularly look at April here, we see there's an increase in temperatures across time. So here we see the last 40 years, but from month to month or from year to year for specific months, there's quite a lot of what we call variability. So in order to kind of use climate information to kind of inform adaptation, you both need to know and, well, to understand both this variability and the trend. So what we know as climate change, human-induced climate change. So if we take another step back, so out of Europe onto the global scale and also further back in time, of course we know that both globally and regionally, temperatures are increasing, and they've increased by about 1.1 degrees since the end of what we kind of sometimes name the pre-industrial period. And what I also want to point out is that when we talk about these kind of reference period where it was warmer or colder than normal, that's actually the period you can see in the dotted line on the right-hand side. So you can see that already that reference that we refer to, because that's the kind of the climate of now, the climate we know, is already quite a lot warmer than the climate on a global scale in pre-industrial times. So one part of monitoring is to understand kind of the long-term trends in the change, but also the variability in time. But at the same time, what we do at C3S is also look across the climate system using different methods like satellite data, in situ data, and this kind of combination of models and data called reanalysis to understand how the climate system is changing, and not only looking at temperatures, but looking at different parts of the climate system. So we look at sea ice, we look at glaciers, we look at river discharge, etc., in order to kind of get this kind of broad and holistic picture of the climate system. And one place where we record this information, so to say, is in the European State of the Climate, is an annual report, which we publish around April every year. So the last one was published in April, on April 22nd of this year, where we look back at the year before, say 2020, and look at that past year in this longer term context. So for instance, we can say that the winter in Europe was really quite extraordinarily warm, and especially in northeastern Europe, so the winter from December 2019 to February 2020. But we also look at how different climate events, like a west to dry transition in Northwestern and Northeastern Europe had not an impact only on, well, it wasn't only seen in precipitation, but also had an impact or visible kind of signs in things like river discharge, soil moisture, but also vegetation growth. So this is one part of the adaptation chain, I would say, in terms of climate information. So we do monitoring of the past and the present to understand how the climate is varying and how it's changing. And we capture this in mainly in these three different products, so our monthly summaries, also in the long-term climate indicators, and in this annual European State of the Climate. And so that's really one step of the way. And I'm sure that other speakers in this session will kind of bring in the other components which are necessary for appropriate climate adaptation. Thank you.
Thank you. Thank you very, very much. And that's great, because obviously we heard about the European State of the Climate at the beginning from Carlo, and it's good to hear about it in more detail there. Now, you talked about having contributions from so many different partners, but of course, the other side of that is that you're potentially answering questions and having to accommodate different areas of interest for scientists, who want, conclusively answering questions, policymakers, and also delivering messages to sort of a much broader audience. So what would you say are two of the top challenges in being able to accommodate that?
I think one top challenge is, what can the data actually tell us? So even though we're looking at the past, which in a way should be easier than looking into the future, there's still quite a big difference in what we can say about different things. So, and for how far back we can go. So for temperature, we can go relatively far back and have global good coverage, whereas for other variables, that is not the case. With the advent of satellites, etc., that kind of increases. And then the other thing is really, it is not possible to, within one product, answer everyone's needs. Yeah. So in the State of the Climate, for instance, we try to do a staggered approach where there's a summary which can be read by, I would say, a relatively general audience, but we also make sure that there is links back to the data. So if you want to kind of revisit the information or maybe dig deeper, then you can reach or do that by accessing that data and the kind of methods behind.
Okay, thank you. Thank you for that very clear answer. And of course, all of that plays into what I take away also from what Carlo said, is this sense of standardization, this quality assurance, and the complexity in processing the data coming from all of those sources. But particularly, I think that's very interesting. So many different users there. So thank you very much, Freya. I will be asking you to come back. Who knows, there may be some audience questions from you. As I say, we've already harvested some from before this event, but you can take a breather momentarily. Thank you so much to you. And I'm going to ask our next speaker to join. Her name is Suzanne Mecklenburg, and she is the Soil Moisture and Ocean Salinity Satellite Manager at the European Space Agency. And I'm so paranoid now that I put things wrongly. Oh, don't share the screen yet. Hang on a minute. Oh, hang on. I was going to say don't, but you're fine. Okay, so essentially that means, so you can hear me, you can't see me, that Suzanne is responsible for promoting and increasing the use of satellite-based Earth observation data in climate science. So I think I'm just going to hand directly over to you. So while I don't know whether you need to stop sharing just so that our tech team can get you on screen. Can you just stop sharing momentarily so they can stick you on, Suzanne?
Yes, just
a reminder to all our lovely speakers, please don't share until I give you the go ahead. You know how bossy I am. And that gives our tech team the chance to get it right. If you can stop sharing, voila. So there you are there. And then I can say something more about you. Your current focus is the delivery of ESA's Climate Change Initiative Programme and developing future programme activities with the Climate Office as the focal point for climate. So there we go. I need to give you your 5 minutes. I'm going to step away, and now you can kindly share your screen. Thank you very much. And I will just make sure that we can see it. We can't yet, but no worries. Just have a bit of a play. Wherever you I'm very good at singing. I could cover for you. Oh no, you're there. There you go. Okay, fantastic.
Okay. Well, thank you very much for the introduction.
Thank you,
Katrina, and sorry to get the sequence wrong here. Actually, I'm the head of the ESA Climate Office. Meanwhile, I used to be the Sentinel-3 and MOS mission manager, and that's very handy because then you have sort of first-hand knowledge about the satellite data that you're going to use. And in fact, this is a little bit what I would like to talk to in my presentation right now here, and make a bit of a case for the various satellite data that we're actually using in providing all these different information about climate relevant research. Most of the activities under the European Space Agency's Earth observation program are in fact related to climate. ESA is of course one of the main developers and providers of spaceborne observations of the Earth, which is very relevant to tackle our quest for a changing climate. And there are different satellite missions available. There's a large number of them available that we are also developing together with the European Commission and working with EUMETSAT. But I don't want you to look too much into the detail of this slide, but the message to pass is that the number of satellite missions developed by ESA and being operated and being planned is enormous, and the large portfolio of observations that are available really supports the research that goes into investigating the changing climate and our future trends, because it always looks like we are sort of not using that many data, but if you really think about the portfolio that we're addressing, that's quite impressive, and this slide should give you an impression of this large variety of different sensors that we're using. Now that brings me a little bit to what I actually wanted to talk and what the ESA Climate Office does. So what do we actually use these information and observations for? The ESA Climate Office is the focal point for climate activities in ESA, and we're running our flagship program, the Climate Change Initiative, since over 10 years now. And what do we actually use that for? So the basis of the climate change initiatives are the essential climate variables, as we call them. Now, these are climate indicators that have been defined by the Global Climate Observing System under the umbrella of WMO. And what they give us is a long-term data record, a robust global satellite-based climate data records. And so far in the Climate Change Initiative, we have addressed 21 of those. There's about 54 of them, and a little bit more than half of them can actually be addressed by space data. And we have now developed a portfolio of 21 different ECVs. In comparison to what the Copernicus Climate Change Service does, our focus is more on the research and development and the pre-development of these climate data records, and we work very closely with our counterpart C3S on this. Now, we also do a lot of cross-cutting activities, and the one that I really want to mention here is our climate modeling user group. The reason being that at the end of last year, we have been selected by the World Climate Research Project to be the host for the Climate Modeling into Comparison project, which was already alluded to by previous speakers today. And that's a very important step in some way, that ESA can actually provide this community service to our member states around Europe to bring climate modeling and climate observations together, which is very important to do because it will help us in quantifying the effect of a changing climate and these indicators that it's based on, but also making a projection about the evolution of climate in the future. And these information feed very closely into the reports that we've heard earlier from IPCC, for example. Now, this is just to give you a bit of a background where we are coming from in ESA, but what I now want to show you is two examples. One where we use satellite data a little bit more that could go into the adaptation direction. And then the second example, I would like to give you an indication how we can use it in improving our estimates of emissions. Now, here comes the first example. We all know that global average sea level is rising as a response to our warming climate. The rate is about 2.6 millimeters per year over global average, which is being calculated over recent decades. But in a new study by Nichols et al. That was recently published in Nature Climate Change, they're using global multi-sensor data for having sea level information in combination with the land subsidence data to determine what they call the relative sea level rise at the coast. And they found that coastal inhabitants experience sea level rise maybe 4 times faster than the global average in some places over the past 2 decades. And that's enormous. But there's other effects that you can see here on this middle graph that I'm showing you, which are sometimes also surprising because, for example, in North America, relative sea level is falling as a result of glacial weight decline, so basically melting glaciers, and land lifting as an effect of this one, which affects essentially 12% of the global coastline in North America, but only a small number of people by comparison to, for example, Asia. So in contrast, 1 in 5 people living along the coast experience a relative increase of sea level of 10 millimeter or more per year, despite the fact that there's only about 1% of the world's coastline in Asia, for example. So that's interesting and helps us in adaptation in a very regional way, I would say, and is probably a very valuable input for any policymakers and decision makers for adaptation. Now, the second example that I wanted to show you, The second example that I wanted to show you is over Africa. And here, so on the left-hand side, where you see the sort of more reddish colors, you see additional small fires that we have been detecting by using, instead of a sensor that we usually use for determining burned areas, MODIS, which has a resolution of 500 meters, but we have then been using Sentinel-2 data, which has about 20-meter resolution. And as an effect, we can see more small fires. So we don't actually see the fire, we see the effect of fire, so essentially the burned area. And that you see mainly in the sub-Saharan Sahel zone here, on the just above the equator. And that's a very interesting result, because that means that 80% increase in burned areas was detected across this area, which is huge, and amounts to emissions that are about between 30 to 100% higher than we had previously estimated, which represent actually 14% of global CO2 emissions from fossil fuel burning. And that's enormous, especially when you think about the reporting that countries will need to do under the Paris Agreement, for example, in the future. And that's my last slide, and that's a bit of a call for saying what comes next, because here's the challenge. The challenge is that we've been set by the International Climate Network, let's say, a challenge in reporting our emissions and our agriculture, forest, and other land use changes under the Paris Agreement. First global stock taking place in 2023, and then the second one in 2028. And this is a huge policy framework for which we need to actually understand how we can report these things as a national determined contribution, but also how we can actually react on a regional and national level. And I'll leave it at that.
Thank you so much. I'm just waiting to not to replace. I've replaced you, but there's no way I could deliver. I'm just momentary. If you could, thank you. That's it. It's always the trick of stopping sharing, and then we can be seen together in the live stream. Thank you so much for that. And again, I suppose picking up on saying, you said that's what I was, but I'm not that now. So I'm just going to ask you for the implementation of the newly established CMIP office. Just harness a little bit, what's the office going to deliver, and how is it going to link with those current activities with ESA? And obviously there you talked about its flagship program, the Climate Change Initiative.
Sure. Well, I should first say that ESA is the host, so we're not actually dictating what CMIP is doing. CMIP is an independent body who needs to provide climate projections in a very independent manner. But what we're doing from ESA's side, we are basically providing a service to our community around Europe. And it also sort of strengthens European leadership in climate research, because if you really think about it, CMIP is currently, I think, encompassing 28 different model groups. And I think more than half of that are actually located in Europe, which is a very interesting fact. So we further the leadership of this one, and they are coming up to changing over into their seventh phase, where they will basically start again from defining what the input is going to be that all the different models will use, and then providing their projections ahead of time. And this is essentially the office will coordinate the different scientific groups around the world. They will not necessarily do the actual model runs or the actual science, but they will coordinate this effort. And it actually tells you how much importance the World Climate Research Project also put on such an experiment to say, okay, you need a dedicated project office to actually handle this enormous effort. Will tell you, this is the underpinning data for future adaptation.
Indeed, thank you very much, and Suzanne. And also, just to say, because when I was reading up before this on these essential climate variables, what was so fascinating to me is that somebody not obviously in this realm, and you hear we all hear about permafrost and glaciers and a bit about rain, but when you actually go into all these variables and you look, fire, land cover, evaporation from land, biogeochemical, physical, so all of those different divisions, ocean, surface, hydrosphere, is absolutely fascinating, and it gives you so much more of an in-depth understanding of quite the complexity of the provision and the processing of the collection of climate data and the delivery, as we heard from our previous speaker, to meet those very, very different user needs. So thank you very much. And you're going to come back. I can wish you good luck in this new role, but we're going to see you again at the end. So thank you for your contribution thus far. You can take a breather. We're just going to have a breather before we hear from our last three speakers in this session. I'm just turning away because I have various papers around me to refer to. We could do another poll, ladies and gentlemen. That would be perhaps just a nice moment to do that. We're looking again at, what should C3S do? And the question that we have here is, should it monitor and report on tipping points in climate? So I'm just going into the app on Swapcard. I'm going to see if it's possible for me, and if it's not, then I'm going to ask the good people behind the scenes to post for me. That would be wonderful. So to monitor and report on tipping points in climate, and I can already see that the audience is busy with a question for Suzanne, so you might catch that, Suzanne, for when you come back. You can see it in the private chat on Zoom. So I'm unfortunately not able to access the poll at the moment for some reason, but if anybody wants to send me the answer, they can in due course. I'm going to move on to now our next speaker, who joins us from the European Environment Agency. His name is Blaž Kurnik. So he can come and join me on screen, but for goodness sake, Blaž, please do not press your share screen quite yet. That would be wonderful. Just give the technicians a chance to catch up. So you've been for some time, since 2010 at the EEA, various different positions. You're currently, please correct me if I'm wrong, I didn't get everybody's bio in before the start, hence sometimes when there are switches and moves, you don't always catch it. You're currently head of Group Climate Change Adaptation and Land Use Change and Forestry. And oh, look, before, there we go. Should C3S monitor and report on tipping points in climate? Yes, they should. 97%, yes, they should. And a mere 3% said no. So what are you going to talk about in your golden 5 minutes, Blaž?
Yeah, thank you, and good afternoon. So I will more focus on how basically translate this wealth of information and data into the policy relevant language. And this is what we do at the EEA, and this is what we are basically trying to bring together all this type of data and then supporting the politicians and policymakers who are our stakeholders at different levels, from EU to countries and of course to the regional level as well. And this would be my talk today.
Okay, so just make sure you're at top volume. For a moment now, I thought you sounded a little bit like you were underwater, but you can share your screen and I'll just keep an eye on that and I will hand the floor over to you. So let's just test that we can see. Yeah, okay, we do see that. That's great.
Okay, I guess.
Wonderful.
You can see it, huh? And
I can indeed.
I hope you can hear me well.
I can now hear you better. Thank you so much.
I will speak a bit louder as well. So yeah, as I said, yeah, I will actually focus on basically adaptation and how basically translate information and data to the policy relevant language. And to do so, I will actually present you a couple of examples. Firstly, more on from the national level, how the countries are doing, regional level, focus on the cities, and then also focusing more on the health aspects of climate change adaptation, and as well on the natural-based solution of the climate change adaptation. This would be like, let's say, an outline of my talk. But we are at the agency, of course, having very close links to the countries. We have member countries which are actually including more than only 27 member states. We also work with other countries. And we are regularly following the progress of the countries, how they are actually preparing and their national adaptation strategies and plans. And this information, which we are collecting through the reporting mechanism, are also publishing at the European Climate Adaptation Platform, so-called Climate Adapt. And by now, and the information from the last year we have, it's like all countries have actually adopted dedicated national policies, being national adaptation plans or national adaptation strategies by now. And many countries are actually also having, almost all countries are also having prepared adaptation in climate change impact assessment for supporting the adaptation. And here they are using various of data sets, including their national data sets, but many of the countries are also using the publicly available European and also global data sets to support that. Some countries, and they are not so many, have started actually looking into the next cycles, looking how to evaluate how good they are in planning and strategies. And some countries are also having actually measuring the progress by specific adaptation indicators. And these are not so many, only like up to 8 countries have dedicated indicators in place. You know that most of the adaptation actions are happening at the regional level. And here the cities and regions playing an extremely important role. And you can see in this graph that, you know, there are many cities starting to act on the adaptation. And one indicator showing that is actually how many cities are signing the Covenant of Mayor initiative on adaptation. You can see that this rise is rather exponential. But of course, this is only one indicator. When we are looking, you know, more in details, then of course the picture might be quite different. But what we know that there is a link between the, let's say, in the vertical level, like from EU national to the local level, there is quite a strong link on that. So that's also quite important. So I wanted to mention that one important aspect, and now being in the pandemic condition is also very relevant, is that we also need to look in the specific sectors, not only on the regional or the geographical levels, but also on the specific sectors. And one of them, important one, is the health sectors. You know that climate change is affecting the human health significantly and will affect it in the future even more. And first level, what we have to do is actually provide the wealth of information to those who actually need to adapt, need to prepare the health plans to start actually preparing the society to be resilient to climate change. And that, of course, we need to start with the data, and then from data to information, and then going into the action. And the European Climate and Health Observatory is one of the platforms which is hosted by Climate Adapt, linking variety of information together and providing this information to the stakeholders, to the policymakers, to the politicians to actually start with that action. And of course, one of the partners of the observatory is also the Copernicus Climate Change Service. And this is one of the examples which we are also then preparing and publishing on the observatory, is not only understanding what would be the frequency of heat waves in the future, but also understanding how the society will evolve and how the different vulnerable societal groups are being affected. And here you can see that basically when we are looking to the most vulnerable societal groups, like based on the age, like those who are like above 65 years are more vulnerable to heat waves, we can see that the total number of those people is increasing significantly. And there are two reasons. Firstly, it's getting warmer, there are more heat waves, but also the society is aging. So we also need to look to these aspects as well. Another thing which I would like to show you, and here is the combination of two different pictures or two different maps. It's actually looking also in the cities, and it's more green the cities are, less are actually affected by the consequences of the heat waves, for example. And here you can see that the cities in the central and northern Europe have more of the green areas than cities in the southern Europe. But when we add next to it the information on the heat waves, and this is coming from the recently published European Climate Data Explorer, which Sam will present later a little bit more in the details, we see totally opposite picture. So the most, let's say, urbanized cities are those in the southern Europe, and here the impacts of heat waves, or the frequency or the exposure to the heat waves, is the highest. And so that's important, which I want to say here, that we need to link different information together. And that's my last slide. It's we need to use the nature to do that, and of course, it's also implementing the nature at different levels. And here also my last slide, which is basically showing the links to recent information which you can find.
Thank you. I'm just going to wait for our good bit. There we are. You need to stop sharing, otherwise somehow I magnificently replace you, which is certainly not what I would want to do. So let me just wait for you to come back momentarily. I was quite cheered there, Blas, to hear you say that there's actually quite good vertical coordination in place between the EU and the national and local level, but as you said, so much of the adaptation is happening at regional level. And also I know very much because of working with the Covenant of Mayors. So just sort of keeping within that framework and keeping within that sort of broader framework, how do you envisage that these climate adaptation activities under the EEA are going to support specifically the adaptation community in tandem with the European Green Deal?
Yeah, the first thing is we need to provide the right information to the right users. Of course, we have to actually link various information together. It's information coming from the Copernicus, but also information and data coming from other sources. And today we are talking about the climate data, which are quite well advanced. They are quite easily accessible. But when we talk to other layers, like social, economical layers, this is not necessarily harmonized across Europe. And here, basically, there's quite a lot to work to do to actually bring all this kind of information together to actually inform decision makers under the Green Deal to start actually implementing right actions at the right levels.
Yeah. And thank you for the very interesting little aperçu you gave there into the heat waves, not just sort of reading when and how historically moving forwards, but listen, how do the different societal groups, how do they respond to this? What do we need to be looking at there? So thank you for that very pertinent example. Don't disconnect, stay with us. We will have a little bit of time for audience questions at the end, because I'm being so horribly strict with you all. So you can just put your feet feet up momentarily, and we are going to hear from another speaker at the ECWMF. His name is Sam Arnold. So Armand, even. So you can't, I corrected it, Sam, before you come on and say that's not my name. You are setting up a sectoral information system, which is providing climate information to all sorts of different sectors: biodiversity, agriculture, coastal areas, fisheries, and so on. So delightful to see you. I think what you're going to speak about is going to be in complement to what we've just heard, but where are you going to mainly focus upon in your 5 minutes?
I'm going to be focusing on a new service that was actually released yesterday evening and actually tweeted about and published today. So this is the so-called European Climate Data Explorer, which is the interface between the EEA's Climate Adapt and C3S.
Fantastic, sounds good. So you are definitely in the right place in the lineup of this second panel. So if you have something to share, fabulous. We can see it.
I do.
Yeah, that's a good start. All right.
Well, that's hurdle one done. So I apologize if it's noisy my end. I work in a shed, so my home office is a shed, and it's kind of a monsoon's kind of swept in since the start of Blaž's talk. So hopefully you can hear me. So,
we will forgive you. Okay, we can hear you. All right.
Brilliant. So essentially I'm going to be talking about the Climate Data Explorer. And this presentation follows nicely on for Blaž's talk and introduces the C3S activity that was just launched last night to provide consistent pan-European climate information, which will support the development of national and subnational climate adaptation plans. So the European Climate Data Explorer is underpinned solely by C3S datasets. Okay, just one moment. I've just got to sort out my Zoom functions. Sorry. That's better. You're taking over my screen, so I couldn't see my notes. Okay, so the Copernicus Climate Change Service contains a wealth of information about the Earth's recent past, present, and future climate, from climate data sets such as observations, seasonal forecasts, global and regional reanalysis, and global and regional climate projections. Okay. Aha. The climate impact indicators developed with user consultation were developed within the so-called sectoral information system activities of C3S. These indicators were developed using core data sets and from the CDS, namely the reanalysis, climate projections, and predictions. A climate impact indicator is an aggregated quantitative measure used to show the impact of climate change on nature and society. And such indicators are commonly used in climate impact assessments, so users don't have to run the whole production chain. The C3S offering also contains a toolbox, which allows users to develop their own applications to manipulate and visualize Copernicus Climate Change Service data. The toolbox applications can also be embedded in third-party websites, such as the EEA's Climate Adapt platform. And here, this is the mechanism we're using to broker our data to the European Climate Data Explorer. The European Climate Data Explorer is hosted by EEA, as Blaž mentioned, and it's a new web portal providing interactive access to selected climate impact indicators from the CDS. The EEA identified 32 high priority indicators to support their member states, and the indices were included in a climate-related hazards indices for Europe report led by the European Topic Centre on Climate Change Impact, Vulnerability and Adaptation. The European Climate Data Explorer aims to enable access to a wide range of data on observed and projected climate change in Europe across various climate-sensitive sectors such as the water management sector, energy, biodiversity, agriculture, human health, and tourism, to name a few. The interactive viewer allows users to zoom in on maps in order to focus on regions of interest, show time series for specific countries and subnational regions, up to a NUTS level region, which is like the smaller principality regions of Europe. This interface allows the export of maps and graphs, the inclusions in adaptation reports, as well as a direct download of data and indicators. The European the European Climate Data Explorer lowers the technical hurdles that may limit access of C3S data for a large part of EEA's target audience. There's planned activities for the second half of 2020, 2021 and 2022, and we plan to expand our offering to cover 32 high priority indicators that were identified by the European Environment Agency. Additional climate impact indicators will be made available using toolbox workflows. The toolbox that we offer has been used to create heating and cooling degree days indicators, and these have been implemented by the toolbox contractor Be-Open. These Python workflows have implemented peer-reviewed methodologies using an ensemble of bias-corrected regional climate projections and ERA 5 reanalysis. This approach allows the data to be kept up to date, unlike other initiatives which use data production offline, and the data can become out of date when new reanalysis become available and new climate projections become available. We plan to implement flexible workflows which allow the climate impact indicators to be updated based on the availability of new CDS datasets. For example, climate projections coming from the new updated Eurocodex or CMIP6. There are also plans to align the European State of the Climate reports as presented by Freya and their climate intelligence activities with the European Climate Data Explorer, which will allow member states to align their climate monitoring reporting strategies. Okay, this is just a quick overview of the portal that was released yesterday. I think it's going to be a very valuable asset to European member states to support their adaptation strategies going forwards. Okay, many thanks.
Thank you very much. And I am back with you. I can see myself. You just need to stop sharing your screen, that's all, and then we get to see you. In fact, it really is doing that I do find that, oh, you can't really see because my stomach's very far down, but doing all of those things sometimes at once, particularly when you've got a monsoon raging and you're in a shed. Nice shed, I've got to say. My shed doesn't look like that, Sam, at all. Good Lord.
Well, it's a nice shed.
It's a man shed.
Is it? Am I unshared? Yes, good.
Yeah, just a quick couple of questions for you. I want to just go back to the heading of one of your initial slides. You said there, come on, this is more than climate data, it's information for adaptation. If you have to emphasize that again, explain it in one sentence, what do you mean by that, Sam?
Well, we go beyond just providing data from reanalysis and projections. We're actually utilizing the power of the toolbox and workflows to actually create climate information, climate indices, that can then be used by the downstream community to actually assess the impacts of climate change. So we're not just providing raw access to raw data and allowing users to make process their own data. We're providing data sets that can be used directly, especially when it's bringing together social economic data, as Blaž mentioned.
Yeah.
So yeah, it's a step along the processing chain.
Okay, thank you. And let me also say, I mean, we were a bit in the sort of the lessons learned phase here, and I'm going to ask you about, how can the lessons that you've learned from the first phase of the C3S inform the future? So
I can interpret this in two ways. I mean, the lessons learned from the European Climate Data Explorer going live is minimal because it went live last night, so I can't really reflect too much on that.
Really?
What I
can't you?
No.
From the privacy of your shed? Come on.
We've got not much feedback so far, but what I can say is that there are certain degrees. There's a difference in requirements coming from user communities as we're engaged in the sectoral information systems, and the requirements coming from Blaž and the EEA member states.
Yeah.
So there are certain differences in reference periods and the selection of ensembles versus bias correction data sets. So what we need to do is, going forwards, align the expectations from the EEA member states and our service offering. And having a flexible toolbox approach will allow us to do that.
Thank you so very much. I am keeping my eye on the clock. Don't disconnect, stay in your shed, because I need you to come back very soon, because we have one more speaker who I'm very eager to hear from. A couple of questions can be sent into the private chat, but I do have, ladies and gentlemen, some questions that came in that were harvested from before the event, which I'm going to. So let me say to all of my speakers, it really is going to be what I call kind of brain box bingo when we come back together for questions. It's 30-second answers as cogently as you can possibly deliver them. So Sam, that was great. Thank you so much. Our last speaker in this session, and it's always we say last, but by absolutely not least, is a senior researcher at the Department of Epidemiology, the Lazio Regional Health Service in Rome. Hello to you. Our speaker is Francesca De Donato. She is studying the health effects of extreme temperatures and climate change on health outcomes, with a focus on exposure modelling and the identification of vulnerable groups. So I'd like you to, what will you focus on in this last 5-minute presentation, Francesca?
Good evening, everyone. Thanks, Catherine. Well, what I'm going to focus on is how we can use climate data to support adaptation in the health sector and to reduce the impacts of climate change on local populations.
Thank you. Do you have something to present for us,
Yes.
I believe? So if we give you a moment to share your screen, and I can then hand over to you to stimulate the brains of our audience. There we go. Right, that's a good start. We can see your presentation. So there we go. I can mute myself. Perfect. All right, off you go. Thank you.
So as we all know, there's quite a lot of evidence, which is quite consolidated now, on how climate change can have an impact on health, both in direct terms when we're exposed to extreme events like heat waves, floods, droughts or storms, in terms of extra deaths or injuries, but also in terms of the indirect effects related to climate change when we have increases in temperatures or changes in precipitation that affect our environment and the ecological environments we all live in, and how this has an impact on the quality of our food, of our water, and how we live. We also know that not all the population around the globe will be affected in the same way, and not the same population within, let's say, the group of people in a city or in a country are affected in the same way, be it by in relation to the resources they have to react to these stressors, but also in terms of their health conditions a priori, especially if they have chronic conditions. So what we know is that the impacts are heterogeneous, and it's very complex to define how to adapt and what measures to put in place. Climate data is of great support to the health sector, not only for research, but also in terms of public health response and policy, not only from observed and reanalysis data that is used to understand and estimate the health risks and identify who are those most at risk, and we can define specific plans and measures to put in place from the different environmental stresses that we've seen exposed really well in the presentations before me, but also in terms of how climate change projections can be useful from the public health perspective, because they give us let's say a vision of how things are going to be in the longer term and how we have to address our investments in the coming years as well. On the other hand as well, forecasts are very useful because they give us an idea of the warnings of when things are going to happen, how the public health sector can respond, improve response and preparedness, and also those emergency responses that are very important when we do face extreme events like heat waves or floods and other events. And then last but not least, the evaluation is a crucial aspect we need to handle in public health, not only using near real-time data to evaluate what the impacts are, but also how to evaluate the effectiveness of the actual adaptation measures we have introduced and how these can be constantly improved as the impacts also evolve over time. As an example here, I've just reported how within the CDS, one tool that we have developed looked at the current and future impacts of heat waves, and it gives a very clear idea for different cities in Europe of how the impacts of heat waves and climate change are going to be in the next decades or coming years, considering different climate change scenarios, But the added value here is that it also shows how adaptation measures can somehow contrast the impacts and the future impacts in terms of mortality and impacts on local populations, really giving an idea to the policymakers on what the impact will be, what has to be done, and where we can really increase support and measures that can be introduced to reduce the impacts on our population. In terms of monitoring of the health effects, as I mentioned before, data is really important for us from the public health perspective, because as we can see here on the left, this is just an example of heat waves in Rome, and how as temperatures increase on a daily basis, the number of daily deaths also go up in a concomitant way, and we can really monitor how things are changing and know how to change response services, inform health services on what to do, what the health risks are in terms of response to heat stress, and which are the people that are going to be turning up in hospitals and healthcare facilities as well. On the right here is another example of how the use of near real-time data or constant and very good quality meteorological data, in this case looking again at temperatures and the impacts of extreme temperatures on mortality, how adaptation measures introduced can actually be beneficial. And here we see how in most recent years, this curve that shows the relationship between mortality and temperatures has gone down. So we see a reduction in the effects, possibly because of the introduction of adaptation plans in Italy, as we've seen in the last years. So really showing how the efforts put towards adaptation measures and response to extreme weather events, and now, but also in future years, can be of an added value in terms of the impacts of climate change on local populations. So just to wrap up very quickly in terms of what climate change data and services can do from a public health and perspective in terms of adaptation, it's really important to have tailored climate data indicators and tools for health. We need good temporal data with long time series to evaluate and estimate the health impacts. We also need high resolution spatial scale data to look at in-depth situations on the ground. So within urban areas, for example, it's important to identify the hottest areas in a city or the most polluted areas in a city, and really address specific measures to those areas and to the populations most in need. It's really important to not, keep let's say, health and climate research and policymakers in separate worlds. We need to engage and improve collaboration and networking, which is crucial, because if we think of adaptation plans and policy put in place, health effects or the role of health is really like, the tail end or the back end, and really that has to be changed in some context to be put in the core aspect of this, because focusing it on what the role of health is and what we can do to reduce the impacts is crucial if we want to have more response from policymakers on adaptation measures as well. This helps not only raise awareness and the knowledge of the effects of climate change on population impacts, but also it helps improve resilience from a population perspective as well. So we really need to make sure that within, we have a more holistic approach in terms of climate change policy and adaptation, linking, broader policies as well on climate change, sustainable development, and even more recently, if we think of it, the COVID recovery for a healthy recovery after COVID, also considering climate change. And with that, I thank you for your attention.
Thank you. Thank you, and thank you for your patience, because you have the hardest job, because you come right at the end and you hear everybody else, but super interesting. And I think what you were saying there, the importance, I think, of a holistic approach resonated there with what we heard from Valérie at the start when she said, handshakes across silos. I thought that was such a lovely image, but very important. You said right towards the start of your presentation, it's complicated to shape how to adapt, it's complicated. And so that's the obvious question to you. Are there any particular knowledge gaps in the health sector when it comes to this climate change adaptation? And if so, how can, for example, C3S and obviously the broader climate services community help to plug those gaps, would you say?
I think, we have progressed somewhat in the last years, and the availability of data has helped that a lot. But what I would say that is important from the health sector is again to have a broader and more comprehensive approach between the different extreme events and different environmental stresses, both in terms of defining the risks, identifying who the susceptible subgroups are, but also in terms of the warning. You know, we usually have warnings for heat, warnings for air pollution, warnings for pollen, several warnings. But then at the end of the day, the people most at risk are the same people. We've seen it for COVID as well, who is most at risk from COVID extreme conditions. They're also the ones that are more susceptible during heat waves or other exposures. So we really need to, you know, bridge that gap, come together and try and you know, unify the different exposures, the evidence and the research that has been done.
And just to say, just very critically, sorry to interrupt, and everybody else behind the scenes, can you get ready to make a brief 10-minute appearance? Very critical for me, because I have to say, Francesca, I hear in every, you know, sector quite rightly, we need to collaborate better, we need to cooperate, we need to look outwards. So if you could wave your magic wand, sorry, I'm speaking a little bit too fast. Why doesn't it happen? Because it's too much energy, people don't want to, they protect data, or they just don't think about it, or there isn't the resource. If you could say, Kat, the one thing I'd like to change to have that sort of broader approach, what would it be?
Oh, that was a very difficult question, I would say.
Sorry, I've opened a whole Pandora's box in the last 3 nanoseconds.
No, I mean, it's a question of the quantity of the research as well that is engaged from every sector, and every sector has their, you know, their priorities, I guess. So I think we're on the same page in terms of everyone knows the risks of climate change. Nowadays, we're quite convinced, and I think it's just a question of getting the right people on the same table and defining what the priorities are for everyone and going ahead with it. We know what the data is, we know the research, we know the evidence. We just need to start doing more, I think.
Thank you for that. Stay with me. Can everybody else come back? I mean, that requires everybody else actually not doing anything. The technical crew has to do something. And I'm going to, Suzanne, just while we get that set up. Isn't that lovely? Look at us. I don't know why I should have to be so humongous and you always tiny little matchbox size. But Suzanne, because time is so limited, here's a question to you, and then some questions that were harvested ahead of time. What's the level of uncertainty? I think you saw that question, did you, come in there? What is the level of uncertainty in relative SLR, given that remotely sensed elevation data has a coarse vertical resolution?
Yes. I think
we lost you. You sound like you're in space quite extraordinarily. Hang on. No, not your fault. It's just speak again.
Yes.
It's so strange. I don't know whether you can. I'm going to ask another question and have a bit of a fiddle, even if you have to momentarily reconnect. Otherwise, I'll be asking you to answer that question just because I can't hear your answer, but I will come back to you. Let's just, in no particular order, let's just stick with this sectoral information. What's the and anyone can pop in here, ladies and gents, keep it short. What's the thinking related to how the climate change information used by the C3S sectoral information systems projects, how can they catch up quicker with available climate projections? What's that dynamic between the two? Sam?
Yeah, so I kind of alluded to that a little bit in my last slide. So there's various initiatives at the moment. We have to obviously include more data into the CDS, but that obviously has to be well characterized, documented, and the metadata needs to be up to date. But once it's in the CDS, what we plan to do is move away from having all the processing of the indicators done offline to actually more flexible workflows. So these workflows have a common element where the algorithm is in the climate data store, it's in the toolbox, and you can kind of plug in new data sets. So it allows us to actually update the data sets for different regions of the world, different climate projections. But at its core, we do have a peer-reviewed, robust methodology to derive the indicators. So I hope that explains something.
Thank you. I'm just going to come, and of course, anyone to come to a second question that came in, prior to this event. Interesting one, and particularly when we think we've spoken about where all of this data, who we are informing, how people need to prepare in different ways, and how, you know, those who are affected very differently. So are the current modelling efforts producing climate predictions that are being taken seriously by those who must fund adaptation efforts? Any thoughts on that? Who would like to, are the modelling efforts being taken seriously by those who have to fund the adaptation efforts? It's a very sort of broad and you know, what's your personal view, Blaj? There, yeah, please go ahead.
I can start with that. Of course, you know, those who are founding or those who are deciding, the decision makers, they want to have, let's say, simple answer because they need to translate this simple answer into the concrete action. And many times what we are providing is a set of answers. And that's basically what we need to do it better. So basically how this kind of information, including the uncertainty, is communicated to those who are deciding. So communication is the topic here. Because many times scientists and also us who are somehow in the middle are basically giving too complex answers. And then, of course, those who need to implement this based on these answers are a bit lost, and they just decide something which is not necessarily always the best. But what I also want to say is that the things are improving. So looking 10 years ago and looking now, I think we are doing, the things are getting better and better.
Okay, thank you. I'm going to, Suzanne, I'll come to you in a minute because apparently they've checked you technically, not you, but your connection, and you are back. Does anybody else want to come in on to contribute to either of those? A very interesting answer there. Freya looks like she might be clicking on. No, you're not. Okay, then I am just going to give Suzanne the floor because I feel you deserve it, Suzanne. It's insane. Let's try again.
I hope you can hear me now. I don't know what happened.
Hear you crystal
Okay,
clear.
I think it's the switch on, switch off trick that everybody does. So I would hesitate to say the uncertainty is a particular number. I think the uncertainty depends on a number of things. If we're looking at projections of sea level rise, we need to talk about different model runs that we are actually having. So as I said at the beginning, this coupled model intercomparison project uses different climate models, and they all have associated uncertainties with their predictions. And that's not something that you can just express in one single number. It's impossible. But then if you go back to observations, each and every sensor that helps us, and it's mainly altimeters, obviously, but also the instrumentation that helps us to determine what the exact position of the satellite is, which is very important for altimeter measurements. They have all ranges of measurement errors in the millimeter range. So we need to be extremely precise, and this is why there are so many altimeter missions, and we are combining these measurements to a global estimate of sea level rise. And of course, you need to think about the uncertainties as propagating from the measurements also maybe into the into models if we are using them to, for example, validate them or on sort of past runs. So I would really hesitate to give one number because you're then always quoted on one number, which can never express the different layers of all this.
Thank you. And just sticking with that and sticking with the sort of a big question came in from a participant, and I'll just read it out. I don't know if any of you have caught it, but over the last 20, 30 years, we've built up very long climate data records. We talked about historical records. We talked about how C3S provides those too. We've brought up many climate data records of physical parameters of the Earth system, but direct observations of weather and climate impacts from satellite are still in short supply. So this scientist who works on climate impacts says, I need accurate observations of location, timing, severity of hydrometeorological events so that myself and my good colleagues can build the next generation of weather and climate impacts models. So what kinds of services, what EO services can we expect in the future to help us in this endeavour? So that's a very, very personal, I don't know whether again, yeah, Suzanne wants to kick off or?
I can start. As I just said, I mean, in terms of precise location. If we were talking about space data, on all of our satellites, we have very detailed instrumentation that tells us exactly where the satellite is. So that should be allocated with the measurements that we're making there. So maybe I'm misunderstanding the question. It would be very interesting to know maybe a little bit of background, and I'm very happy to be in touch offline to actually provide a detailed answer to that one.
Okay, well, that is the beauty of Swapcard. I am sure that C3S can put you in touch, or at least curate the bigger question around that. And then perhaps, as I see, and you're absolutely right, you don't want to be quoted on something or particularly answer something when the full facts aren't there in the face. So we have barely a couple of minutes left. What did you not get to say for this climate impact assessment and adaptation, this first kickoff thematic session? Anything that you want to say as a last sort of, the next phase of this project? If you could wish a wand within your own sector of work, how do you see things evolving? Maybe Freya can tell us, if we were to take a photo of your flowers in April 2022, what do you think they would look like? A last audience takeaway from you on what they need to think about to nourish their own work. Sam, start with you. Just a moment, just a golden nugget of a takeaway before I close this session.
I think I got the short straw there. Being part of the spot is not my forte, but I think what we need to do is work with the EEA closer. I think there's been a good dialogue over the last couple of years, and I think the European Climate Data Explorer is a first good opportunity for us to produce a portal and interface that can be used by EEA's member states to support adaptation. Now, obviously, this can evolve. And what we're providing at the moment is not the panacea, it's not the final product. But I think as it becomes more useful and more popular, then we can certainly get some excellent information and feedback from them.
Thank you. Okay.
Yep.
No, sorry, go on.
No, that was it.
Okay, so I was going to come directly to your colleague. I was going to ask Blaj, what do you think about that better, and the relationship between and how?
Yeah, I think we are progressing very well. I think we can showcase what we have done and what we are planning to do. And of course, working together is the answer, because on one hand, the wealth of information needs to be translated to the policy relevant language. And this means translating the complex information. This means translating the uncertainty, and then also translating how this information has to be used for concrete actions. Because like I showed, all the countries have strategies, have plans, but what is still missing is concrete implementation of the actions. And every year what we are waiting, we are losing, because the climate extremes are getting stronger, and we are getting more and more losses from weather and climate extremes. And that's basically, it's a time to act.
Time to act, I know, and this is the thing that we hear, and it's almost what Francesca was also saying at the end of her presentation. Last word from you, Francesca, please.
Yes, I mean, from a user perspective, down the line, let's say, as I said before, I would envisage a better collaboration from the end users on the different actual indicators and tools that we need, not only to better support the research and monitoring of the current impacts, have a systematic evaluation of what the impacts are from different sectors. I mean, I can speak from the health side of things, but having an annual updates on the impacts of extreme weather events, I think is really important to get policy moving, and having a better vision of what is going on, a constant monitoring of what is going on as well, not only from the climate change data, which is constantly updated, but also from the impact side.
Yeah, thank you. Freya.
Yes, we're going to talk about my flowers in my garden next year. It's unlikely that I will be there to observe them, because I'll probably be observing in other gardens. But I just want to make that as a point of, for this monitoring to be there, it has to be continuous and kind of all-encompassing. So kind of activities at C3S for keeping these things operational, but also activities such as the ones that undertaken at ESA for pushing the envelope further, so that ultimately we can take up new operational activities of the state of the art and kind of keep that state of the art moving forward.
Thank you. Katja, you've been silent for a very long time, most patient since you presented at the start. I'll come to you. I'll give Suzanne a last tiny second of a word, and then I will close for our good audience. So yes, Katja.
Okay. I just basically wanted to follow Francesca, because I'm really also a big fan of thinking about a monitoring system for climate impacts. So not just climate change, but really the impacts, and focusing on separation, what is really the effect of climate change and what is the effect of the socioeconomic drivers. So really in the sense of attributing the observed changes. And yeah, I think based on all the data that are becoming available, we may be able to build something up in this direction.
Thank you very much. Thank you. I love that. That was quite sort of, basically, I think we might be able to do that. That was quite a pensive end rather than a total woohoo end. And Suzanne, any last, now that we know that we can hear you and you don't sound like you're underwater, anything you didn't, any last sort of trinket that you can give to our audience before I close?
I think what became very clear from many of these presentations is that we already have a very good link between the data providers and decision makers, but I think there still needs to be a little bit more of translation to be made to people who might not in the first place understand space data so intuitively like we do, because we're working in this area. So I think maybe there's still a bit of education to be done.
Yeah, and I think it's something, Blaž, you're nodding there, and that seems to be something, one of the main messages, one of the main points to come out of this is there is all of this data, but the translation, the communication thereof, and sometimes when you answer that question, you know, Blaž, is it being taken seriously? Well, sometimes, it's just overwhelming. So decisions are perhaps being taken not on the right basis. So listen, I thank all of you so very much. As I said for the opening session, I have barely scratched the surface of the content of your considerable brains and incredible expertise. And I know that I sort of terrified you all into not speaking more than a nanosecond over your allotted time. So I am very, very grateful to you for that. Genuinely, it makes a moderator's job easier. And if anybody needs to continue with these good people a conversation, then please do ask how that's possible in the chat. And don't forget that presentations for all of those speakers who are happy to share them will be permanently available in a few days on the C3S website and up until the 4th of June on Swapcard itself. So you can all take a beautiful break backstage, and for your patience and your erudition, I thank you for that. We have reached the end of this epic day, ladies and gentlemen. Do continue to have a play around on Swapcard, because you can, of course, schedule meetings with participants, with speakers, with partners in booths. So you can do that on the platform. Have a little bit of a snoop around. You can also, if really you just loved it so much and you want to spend all night re-looking at these two sessions, you can do so, because there are recordings available on Swapcard and shortly on the C3S website. So I will just do a quick thank you, of course, to C3S, its co-host, the Italian Copernicus National User Forum, all the partners, to our technical wizards behind the scene, Adria Congrex, Oiko Service, to all of you, particularly at C3S. I know Samantha Burgess has been working like a fiend to bring some of those questions to light that have been coming into the chat, and her colleagues. And thank you to the sterling audience, to all of you for turning up, not just registering, but actually tuning in. I hope we will see you tomorrow. If we don't, please do access the evaluation form that you can find on Swapcard, or you'll find it coming into your inbox. We'd like to know how you'd like to shape future events to your needs. But tomorrow, if you like what you've seen, then you've got to be back. We'll start by focusing on climate extremes. 90 minutes, we'll close on climate resilience. So we're drilling down more into the detail, all things that have been mentioned today, but we're going to unpack them much more robustly, more dazzling speakers, more stimulating content, more opportunities for you to network and to ask your questions. But for this evening, Twitter, hashtag C3S21. So do share your gems of wisdom. Tomorrow, 14:30 CEST sharp, I'll be here introducing another fabulous lineup of experts. So hopefully, ladies and gentlemen, see you all then. Wish you a very good evening.